2023. In blue color line shows how the number of dengue cases vary in year 2022. Like this way, it has 3 lines. Now, see, without knowing anything about statistics, right? Without knowing anything about the subject statistics, by looking at this graph, this is my x-axis and this is the y-axis. X-axis I have the time V, and the y-axis I have the number of dengue patients. Right? You can get more information. Right? Here from 2021 to 2023, number of dengue cases are high in these weeks. Right? You can find what are these weeks, in which years, right? Number of dengue cases are very low in this here in 2023. In these weeks, number of dengue cases are very low, right? From week 1 to week 29 in year 2022, right? This blue color line shows the dengue cases in under year 2022. So we can see from week 1 to week 8, it shows some decreasing pattern. After that, it again shows some increasing pattern, right? Up to this week, again it decreases. Like that, we can get how the dengue cases vary, number of dengue cases vary. So this is also another graphical, we say the graphical representation, how the number of dengue patients vary within Sri Lanka, in district-wise. Right? This color shading, the shading, you can see this color range. It shows this is light color, right? Red color. This color shows if this color shows in some region, that means in that region number of dengue cases are greater than 1,000, right? These regions number of dengue cases are in between 3 and 30 for the year 2022 April. Right? This is how we convert. Right? From all these outputs, what you can say, as a summary, I can say that I have some information, right? I convert those information into several graphical and tabular outputs. And by looking at those outputs, we can come to some conclusions. We can get some decisions. Right? So in statistics, mainly we do this part, right? We call this as the descriptive statistics. We call this thing as the descriptive statistics. Descriptive statistics, right? Here, descriptive means we describe some information. We describe. So I will explain you, before going to talk about the data set, I will explain you what are the learning outcome, what you are going to learn under this section, descriptive statistics. Distinguish between inferential and descriptive statistics, these two terms, and identify different scales of measurements. What is meant by the scales of measurements? And explain different methods under the descriptive analysis, calculate mean, median, mode, and skewness measures, positive skewness and negative skewness, and what are the meaning of these, right? And describe and interpret the different measures of variability, what is meant by the variability and how we calculate it, how we describe it. These are called as the range, variance, standard deviation. We called as the measures of variability. So you will learn these very important data analysis points under descriptive statistics. Using these things, like mean, median, range, variance, standard deviation. We can describe our information. Okay. Let's go to the lecture. Right. When I want to show you, say you when I am doing the lecture, if you want to ask anything, if you need any clarification, you can ask, right? Because when we I think this is a new parts for many of you. Some of you have some knowledge about the statistics, but most of you, I think, don't know these things. So if you have any questions or need any clarification, please talk, right? Or you can send me you can put a message to the chat box, right? Right. Please read this definition. What is mean by statistics? And what are the data? What is mean by data? Right? Please go through this. Right. What is statistics? Right. There are several definitions for statistics, but this is a one definition. It covers all the thing. Statistics is a set of procedures for gathering, means collecting, measuring, classifying, computing, describing, synthesizing, analyzing, and interpreting systematically uh, collected quantitative and qualitative data. Right? If I simply say in statistics means, we say it's a science of data, right? The very simple definition for the statistics is science of data, right? Science of data. Then what is mean by data? Right? Data means some information that has been collected from some survey or some experiment or some historical records, or we can collect the data from annual reports, central bank annual reports, census department reports, Department of Census and Statistics. We can collect the data, or you can perform some experiments and collect the data. Right? Or we have sometimes we have to face some surveys. Our Department of Census and Statistics, they conduct several surveys other than the Census and Statistics Department. Several private organizations also, in university students also, they collect data, collect information, doing surveys. Sometimes they distribute the questionnaires, right? We will get several questionnaires to respond. Suppose in a certain factory, right? In a certain factory, the manager wants to identify the employee satisfaction. Employees satisfaction. There are employees in the factory, and the manager of the factory wants to identify employee satisfaction about the factory management, or employee satisfaction about their salary, right? Or their management. So then how we collect those information, right? You can prepare some, you can prepare a set of questions and talk with each and every employee and collect the information, We call these as data. We call these as data, right? So we say statistics means the science of data. In statistics, what we do, we collect data, we collect and we classify, we collect data, we classify data, and we analyze those data, and finally we do some interpretations regarding our analysis, interpretation. So if we simply say statistics is the science of data, and what we do in statistics, we collect data and we classify or we organize those data in some way, and we analyze those data, and finally we interpret our outputs. This is what we do in statistics, right? So data means some information, right? Now I will show you some information or two data sets, two set of information or two set of data sets, right? In the next two slides, you have the first slide, you have the collected data set. This is this table shows you a data set, some information, right? What information here? It has 6 columns and several rows. And the first column shows the student number. The second column shows the Z-score value. Then the third column, gender, right? Gender of student, whether female or male. So this is the district of the student, school type. And the last column shows the average monthly income of a family. So what this information contains here, a researcher has collected some information regarding the set of students, a group of students, right? Here he has collected information from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 number of students who has done A-levels, right? Suppose a researcher wants to identify, he has some objective like what are the factors affecting to Z-score value of a A-level pass student. Right? Suppose as a researcher, I have this question. I want to find out what are the factors. According to which factors the Z-score value of a A-level pass students can vary. What are the factors affecting to the Z-score value? Right? So to find out the solution for this, what this researcher has done, he has selected 10 number of A-level pass students and collect this data, right? So he has the student number collected for each and every student. We want to collect the Z-score value of the student. Other than that, he has collected this information. Right? We can think about like the student Z-score value, A-level Z-score value can vary with the school type of the student. Right? It can vary in practically, right? In general situation, I can think the Z-score value of A-level pass students can vary according to several factors. Sometimes it may vary according to the gender, whether the student is a male or female, his district, Colombo district or Kandy or Galle or Jaffna, According to the district, it can be vary. According to school type, it can be vary. According to the average monthly income of the student's family, Z score can vary. Right? So we can, when we have this type of a problem, normally what we do, we go through the literature. We read some research articles related to this problem and get some idea about how the Z score of A-level student can vary and what are the factors as a researcher I want to collect. Right? So this researcher has collected with the Z score value, he has collected these 4 factors: gender, district, school type, and average monthly income. Right? So here you can see this data set. This column shows some factors and the row shows our individuals. That is I collect the information from student. So this is the first student information. His student number 105326. His Z score value 1.07. This student is a female. His A-level, the district she has sent for the A-level Gampaha district. The school type is a central college. Average monthly income of the family 65,000. Like this way, I have information regarding 10 number of students. We call this is a data set. Right? This is a data set. Any questions? Right? So if I say you how we collect this data set, I can say that we can select we can select 10 number of students, right? And we can distribute a small document with asking questions. What is your Z score value, right? What is your gender? What is your district type? What is your school type? What is your average monthly income? By asking those questions, we can distribute a small document. In statistics, we call it as a questionnaire, right? In statistics, when you go through several statistical textbooks, you can see how we develop a questionnaire, and we can distribute among these students these questions, and we can collect those information. We can collect those data. That's how we collect the data in statistics, right? Because to draw these type of graphs, to draw these tables, so get these graphical outputs, we need the data, right? We need this type of data. Right? So this is a very small data set. And the second one, this is also another data set, right? In this data set, normally you can understand normally this rows shows some information related to some students or some patients or people or some plants, right? For any object, related to any object, according to our research study, we have some information row-wise, and column-wise we have the collected, those informations are collected under several factors, right? The first column shows pulse 1. The second column shows pulse 2. These are the, we can say, this is a simple Excel sheet. Here, pulse 1, pulse 2 are the pulse rate, right? And the third column name, ran. Fourth column, smokes. These columns has some name, weight, height, activity. But you can see under these columns, we have some values, data points. right? If I say the story for this data set, actually this data set has collected by performing some experiment, right? In a certain university, they have selected several students. Here we have the data collected from 25 number of students, right? 25 for 25 number of students, we have the data. In that university, they have collected, selected 25 number of students, and first they record their pulse rate. This is the pulse one, right? Then they ask the student to flip a coin, right? If the coin gets head, for those students, the researchers said that run in the place 1 minute, right? For some some students who has get the head, they ran in one place, and the other student did not run in one place, right? After 1 minute time period, right, in this experiment, after 1 minute time period, again they recorded the pulse rate. This is the normal pulse rate, and after 1 minute time period, this is the, again they have measured the pulse rate. Some student ran in the place 1 minute, others not, right? And the third column mentioned that 1 and 0 means, so I think that is 1 means ran in place, right? There is another number, it is not here, right? Because this is a part of the data set. There should be another number, that is the 2 means did not run in the place. Like this way, I have some information regarding, in this column, I have information regarding whether this student ran in place or did not run in place, right? After that, they have collected these informations also from each student, whether he is a smoker or non-smoker, his gender type, whether he is a male or female, each student height, each student weight, and each student activity level. Here, when collecting the data, they have collected this information using the numbers like 1 and 2, 1, 2, 3, like that, right? In this column, smokes, 1 means suppose smoke, yes. 0 means smoke, no. Like this way. 6, this column, 1 means like suppose male, 2 means female, right? In activity level, we have three numbers, right? 1 means activity level a lot, right? 2 means moderate activity level, right? 3 means activity level very low, right? So instead of typing these text, right? When the researcher collecting the data, he has collected the data like whether the activity level of the student is low or moderate or low, like that. But here we can see we collect the data by performing the experiment. But here you have we have to analyze the data. We have to enter those data into some statistical software. Suppose Excel, right? This is a Excel worksheet. In the Excel, as the columns and the rows, we have the data. When entering your collected information to the Excel sheet, right? It is difficult to write this student activity level 2 means moderate. The second one also moderate. Third one low. First one a lot. Rather than typing these text values, what this researcher has done, he has used some 1, 2, 3 codings and enter the collected information. We call these as some data coding, right? These are used when after collecting the data, when entering the data, we convert those text values into some numbers and enter the collected data to the statistical software. Right? Excel also we can use to get those graphical outputs. So this is another data set. Right? So now you can, when you go to the next slide and go through these outputs again. The first output and the second one, pulse 1 and weight, and this one, these two tables, you can see these are, right? This is actually this data set, the complete data set contains the information regarding 92 number of students, right? Complete data set. Here I have 92 number of rows, but in this slide it contains only 25, right? Using those 92 number of records, these graphical and tabular outputs are created, right? Please get 1 minute and see what this output says related to this second data set. Right? Go one by one and see what you can say, what you can see from this first graph, what it presents, what it says you. What are the information presented in the first graph? What are the information presented in the second graph? Right? So please go through these outputs and compare the outputs with this data set. If you have any questions, you can ask, right? Get 1 minute and compare the outputs with the data set. Right? And tell me what you can see, right? What you can see, what are the information presented? What are the information present in the first graph? In the first graph, what are the information present here related to these students' experiment? Which information present? Which information shows or which information summarize using this first graphical output, this output. Using this graph, what you can say, what it presents. What you can see. What this first graph, use by looking at this first output, first graph, this one, right? What you can say. What is the information present here? Which information present here? What do you think? Which is information present here? Here we have several information in the data set, pulse 1, pulse 2, right? Then RAN, smokes, sex, height, weight, activity. Which information present here? So what you can say, what you can say by looking at this, right, without, still you know how we draw this output, but by as a general student, right, or normal people, what you can say by looking at this first output, first graph, what you can say. Here, this graph height, this bar height is this. Within the bar, it shows 30.43%, and within the bar, it shows 69.57%. Is it difficult to understand? If it is not clear what I am saying, please tell me, right? Right, I will say this one, right? I will give the answer here. We can, this graph summarize the information smoke, right? Here you can see smokes. In the smokes, under the smokes, we have ones and twos. I say one means smoke, smoker, zero means non-smoker. Right? Only two categories, and using this bar, it shows, right? Using this bar, it shows smoke regularly, that is smokers, right? Smoke regularly. This percentage of student, this bar height shows you this percentage of student, that is 30.43% of student are smokers, smoke regularly, right? The other 69.57% students are, this height of the bar shows, right? This shows 69.57 students are do not smoke regularly. Right? If it's a non-smokers, do not smoke regular, right? So what we can say, within this student group, the higher students are do not smoke regularly. The percentage is 69.57. That is the conclusion I can give by looking at this this graph, right? But can you say it by looking at this Excel sheet? Can you see, suppose here, since we have only 25 number of student data, right? Out of 25, I can count how many students are smoke regularly. Yes, 1, 2, 3, 4, 5, 6, 7, 8. 8 students are smoke regularly, others are not smoke regularly. I can count. But when you have 92 number of data points, can you count it? It is not possible. Practically, we cannot count and say how many smokers are there, non-smokers are there, right? When we talked about the data sets, you will get large data sets. You will have large number of 1,000 or 10,000 number of data points may be in your data set, rows, right? All with several columns, several factors. So to summarize or to describe what this data set contains, you should know some statistical concepts to analyze those data. Right? By analyzing this 92 number of the data, I got these outputs, right? We can learn how we draw these outputs in other slides, right? So this is what this output says. So now can you tell me what can you say from which information present from the second figure? From the second figure, what it shows. It summarizes what? In x-axis, for the x-axis, what you have? This is xy plane. For the x-axis, what you have? What is the factor? you have, what is the information you have for the x-axis?
Weight.
Weight, right? For the x-axis, you have the weight. Weight means this column, right? You have the student weight in this column, right? For here 25 number of students. Suppose this plot shows for the 92 number of students, right? I have the part of data here only. For the y-axis, what you have? Y-axis, you have
Pulse.
right. Y-axis, you have the pulse 1, and weight. So what this plot shows, right? For these students, pulse 1 and weight data are present from this output, from this graph. That is, for the first student, pulse 164, his weight 140, right? From the x-axis, I mark 64 and y-axis 140, right? For the y-axis, suppose y-axis value weight 140. So I want to put a dot here, right? So like this way, these dots shows 120 when the weight, this is wrong, right? The weight is 140 and pulse 164. Weight is 140. Right, 140. Then for the weight 140, pulse 164. 64 is a value like here, right? Then you will get this the one data point. So one data point. Like this way, there are for the second student 145 for his weight 145. What is the pulse one? Pulse one value 58. These paired data are plotted here, right? Now after completing this graph, I can get some idea about when the weight increases, right? For this axis, weight increases. When the weight increases, what will happen to the pulse one, right? Whether it shows increasing pattern, or when the weight increases, pulse one also increases, or it decreases, or there is no pattern, like that. Lot of things we can identify. Right? I can say there is a student, his weight is this value, and his pulse one is this value. Right? So we can get some information. We say we are analyzing the collected data. Is it clear? And now this graph, this table, here we have two tabular outputs, right? This table summarize usual activity level. This table summarize pulse 2, right? That means here I have the pulse 2 column. Pulse 2, I have some data. Here I have the activity level. So how I summarize, right? I want to know how many students having activity level a lot, or percentage of students activity level 1 lot, percentage of students activity level 2 moderate, percentage of student activity level 3 low. I want to get some information like that. We say it's analyzing the data, right? So when you go to the this third output, it's a table. Here simply you can see activity level slight, moderate, a lot, right? And rather than saying low, it use slight, moderate, a lot. For these three categories, we have these number of student, all the student total number is 92. Out of 92, 21 number of students have that activity level a lot. 61 number of students out of 92 moderate activity level. This is it's as a percentage value. Right? So we say it's the summarizing the collected data activity level. Right? So the third one, pulse, the last output, fourth one, it's also a table. It shows some information regarding this pulse 2. Right? In the pulse 2 column, I can see several data points, 88, first student pulse 2, second student pulse 2, 70, third student pulse 2, 76, like this way. I have several data points for the pulse 2. Now, how I summarize it? I want to get some information about like what is the minimum pulse 2 value? What is the maximum pulse 2 value? And who is the student having maximum pulse 2, the highest pulse 2 value? Right? So what you can see, if we consider 25 number of students, they have different values for pulse 2. We say it has some variability. Right? And we can talk about what is that variability. And to represent all these students, if we consider one single student, what is the average pulse 2? So we can talk about this pulse 2 information of factor pulse 2. We can talk about it, get some information by looking at this table 4. Right? Here it says, if we consider the pulse 2 of 92 number of students, the minimum pulse 2 recorded is 50. Maximum pulse 2 of these student, out of these student, there is one student having 141, no more. Right? I don't know how many students. The maximum pulse 2 value, the student has 140. Mean, no average, pulse 2 value for a student is 80. Right? This is like the variability. We can talk about this. Right? So these are the things mainly we are going to talk about under descriptive statistics. Right? So first, to summarize get these graphical outputs, now you know you should have this type of data set, right? And how we collect those data set, how we collect it, right? From some annual reports, you can collect this type of data, right? From some research publications, sometimes these type of data sets are available. Or sometimes you have to conduct an experiment. Suppose you want to say there are, suppose you have you are planting tomato plants, right? You want to know which you have 3 types of fertilizers, right? Suppose you have 3 types of fertilizers. As the farmer, farmer can use 3 types of fertilizers, right? I'm planting tomato plants. Right? So I want to find which fertilizer type. These are fertilizer type. Fertilizer type A, B, C. I have 3 types. The farmer wants to know which fertilizer type gives the highest yield, highest tomato yield. Which fertilizer type gives the highest fertilizer yield, right? By experience, the farmers can say sometimes, right? But if you collect the data and analyze it, and as a statistician, you can collect the data for this and analyze, and you can get some conclusion. Which fertilizer gives the highest yield? Right? So for that, you have to consider tomato plants plots and apply those fertilizers. And after some time period, you can collect the data regarding the tomato yield. Right? After collecting those data by performing experiment, you can analyze those data and come to the conclusion whether these three fertilizers gives the same yield, or which fertilizer gives the higher yield, which fertilizer type gives the very low yield, minimum yield. Right? So sometimes you have to collect the data by performing some experiment. Sometimes you have to collect the data by doing some surveys, like employee satisfaction about the factory management. Right? Like this, what are the factors affecting to the Z score value of A-level pass students? You have to collect, you have to do some survey, right? You have to conduct a statistical survey and collect the data. Right? So, this is what we mainly do in statistics. To analyze the data, first you need some data, collected data, right? So you will learn how we collect the data, what are the data collection methods, and after collecting the data, how we analyze those data. Right. Any questions you have? Right. This is actually this is a very interesting subject area, right? And this is very helpful when you are doing your final year. If you have to complete a final year research project, right? You have to work with some data. And you have to analyze the collected data set. In your working place also, sometimes you have the data, collected data, and you want to analyze those data and come to the conclusions. Nowadays, all the firms they are collecting their information. Their daily production, right? Now, regarding the employees, they always collect data, and they keep those data as databases. What is the information, what is the importance of this? Because they want to get some idea about their firms, right? How it is going, what is the future, right? What is the future of their production, right? What is the future of their sales? So, to get some decisions, future decisions also, the data is very important. So today we say, all the people work with the data. The data is really very important, right? Because many areas, they come to the decisions based on the collected data. So, and as a student, right, in your degree also, when you have to complete your research project, definitely you have to do some statistical analysis part. So this is very important for you. And I will show you some statistical softwares, right, used for getting this type of analysis. That is, we call this analysis as data analysis, right? This is one software, right? You will, when you go to third year and fourth year, you can find those softwares, right? One software is like Minitab. Minitab 16 statistical software. This is the Minitab software. Right? This is Minitab. Called as Minitab 16. Another software we have is SPSS. We have no originals, right? But cracked versions. We have SPSS 21. These are we have no originals, but they are, and for the statistical analysis, you can use Excel also, right? Right here you can see in Minitab, right? Like here there is a worksheet like Excel, right? In the worksheet here from the first row, and these are the column, you can enter that data sets into these worksheets, and there are several menus here, right? Stat menu. You can do several statistics, calculations, and graph you can get like those graphs, bar chart, the graph you saw in the slide, like scatter plot. These graphical outputs you can get, right? Rather than getting these manual, you can use, if you know the theory, right? If you know the theory, you can use a statistical software and very easily you can analyze your data, right? But in this unit, you have to learn all these things, how you get these outputs manually. What is the theory behind it, right? After that, you can find some software and do all these things by your own, right? So this is the Minitab software. And there is another software like SPSS, right? IBM SPSS Statistics 21, right? In your fourth year, this third year, fourth year, you have to use these softwares very easily, right? You can use those very easily because these are menu-driven versions. Simply you need to enter the data and use some menu and get the outputs, right? So click here, type in data and click OK. And now you can see here. Here also I have like Excel spreadsheet, right? In the bottom left-hand corner in the bottom, I have data view. In the data view panel, here we can enter the data, right? Row-wise, you have the individual information. Column-wise, you have the collected data for the factors. And here also we have the menus. By going through these menus, we can get, when you click on these menus, we can get some outputs and do the calculations, right? This is also very easy to use. And there is Excel also. In Excel, we have, in Excel, we can use Excel for the statistical data analysis. In the Excel file, right? In the Excel file, in this spreadsheet, as I showed you in the example data set, we can enter the data, and there is a add-in, right? Under data menu in Excel home, insert, page layout. Under data menu, you have the right hand corner, you can see data analysis add-in. When you go to file, options, and you can get this add-in, right? Add-ins to the Excel data analysis tool pack, right? Then if you have this add-in in your Excel, you can get it to the Excel by going through this way, Excel options, add-ins, and get the data analysis, right? So, and when you go to the data analysis, click on this, it shows several statistical analysis you can do. right? For these things, you want to know the theory, right? This is also very simple to handle. And there is another important statistical software nowadays heavily used by the research student, R and R Studio, right? R and R Studio. Right? There are several statistical softwares other than this. This is freely available. You can download this. First download R software and get the R Studio. But the thing is, this is, although this is free, this is like you have to use, it is a programming language. Right? It is a programming language. You have to write some codes if you want to get some output, some calculations. You have to write some simple codes and get the output. This is the special or important point is this is freely available. You can download this, right? Like here, we have to write some codes here, like C++ programming, write codes, what you want to do, and run it, and you can get your analysis, right? So this is a little bit difficult, but other than for your level, these are very, very helpful statistical softwares. Right, any questions? Right, so on the next slide shows you statistical data analysis means we use the statistical data analysis methods to manipulate, summarize, and look at the data, investigate about the data. So by summarizing those data, by analyzing the collected information, what we can do is we can get some decisions, right? We can get some decisions based on the data based on the data analysis. So what is the role of statistics, right? It is very important, right? And it has wide applications in many areas, right? Wide applications in almost in all sciences, right? Biological, education, economics, business management, in meteorology, right? We know when we know the in daily we get some weather forecast, right? We get some weather forecast from the Met Department. What will be the rainfall for tomorrow, right? What is the average temperature for tomorrow? How they give that information based on some past data, collected data, right? Over several years, throughout the months and days, they have the collected data for daily rainfall, daily air temperature, the precipitation values. So they have the stored data, database. By analyzing those data using some statistical method, they do the future forecasting. Right? In the business management also, in the business, they when I perform in some business, I want to see what will happen to my sales in year 2027. So how I get that decision, right? I want to get the decision the most by experience also the management can say, by experience they can say whether it is increasing or decreasing in next year. But the important thing is, if you get this decision based on a reliable way, rather than the experience, based on the data, it is more important. Because we give the decision based on the collected data, right? So to get these decisions in many areas, we need the statistics, right? And in planning and planning, right? So in planning section, in planning, the statistic is very important. In these areas, these are the several examples in under the economics, business, under industry and mathematics. They use statistics heavily, and there are some examples here, right? You can go through this. Yeah, in economics, they want to they collect the statistical data and they use statistical techniques to solve some variety of economic problems, like what will be the prices in next 2 years, right? What is the pattern of the price? What is the pattern of the wages? And so how we get this decision, right? In the business, right? Under production control, and in the production, right? I want to find out, study, right, the needs and the desires of the consumers, right? I want to get some idea about the customer satisfaction about some product. So we have to collect the data and analyze. And in the industry, in the production line, right, we know they do the quality control, right? In the production process, they produce items, right? And the factory, the production manager, right? Management, they want to identify the percentage of defectives, percentage of defective items per day, right? From the machines, right? They have several machines in the garment factory. You know that there are several lines. They produce garments per day. These lines produce garments, and they check how many defective percentage in each line by collecting the data, right? By looking at those analyzed data, they can get some. They can think about if there is a high defective percentage in some line, right? They can think what they want to do, what they want to change, what is the fault, where is the fault, right? So for these things, data and the statistics is very important. So this is a homework for you, right? So write down, find out several applications in statistics, right? When you read research, when you read some articles related to the plantation management, or when you go through the newspapers also, you will see several statistical applications, right? Try to find out where these statistics we can apply, where the statistics can apply, what we can do from the statistics. Right, any questions? Right, next we are going to talk about, before going to learn how we get these outputs and graphical outputs and the tabular presentations, you want to know about the differences between the data points, right? This is very, very basic thing in statistics, right? Because you know that when I go through this simple data set, right? See these two simple data sets. Okay? Here you can see in the first data set, all the data points are Z-score is recorded as some numeric values. And for other factors, gender, district, school type, monthly income, for these factors, data recorded as some, we said text figures, some text. school type or some text. The average monthly also, average monthly income as a numeric data point. Right? But in the second data set, all the data points are like numeric values. Right? Here 64, 58, 62, pulse 1, pulse 2, RAN also 1, 2, smokes 1, 2, activity 1, 2, weight like numeric values. So data, when we look at the data can be in different types as numerics and some text, right? And there are several types of data. And you cannot draw this type of a graph, right? Here, this graph is correct and it is meaningful. Here, I draw this graph for the smokes, to present the smokes, right? Smokes data. It has only smokes data. It has only 1 and 2 values. Data points are 1 and 2 values, right? Could you please tell me, can I draw this type of a graph, right? Here, smokes factor, it has only 2 categories, smokes regularly and do not smoke regularly. So I present the data points, 92 data points as a percentage for these 2 categories using this graph. Could you please tell me, can I draw a graph like this for the variable, for the factor activity? For the factor activity, can I draw this type of a graph, factor activity? Is it, if I draw this type of a graph for the activity, is it meaningful or correct? What you can say? What you can say? What do you think? Can I draw this type of graph for the activity? I can do, right? I can draw because activity has only 3 data points, 1, 2, 3. Here, instead of 2 bars, I want to draw 3 bars. This type of a 3 set. Right? So, for this data, this graph is meaningful. For this data, this graph is meaningful. But I can say you, for the pulse 1, this type of a graph is not meaningful. You cannot draw that type of a graph to present pulse 1 data. Right? So that point is important. That is, when you have this type of a data set, first you need to identify the types of the data, right? Whether they are text or numeric, and there are several types also. According to the data type, you will get different outputs. Right? Now we are going to talk about what are the data types we can find. What are the data types we can find? Right. So, right. And for this, I will explain this term later after explaining the data types, and we can do some exercise also, right? So please read the points in this slide. I will explain you, go through these points. what it says, basic concepts of statistics, raw data, right? Another term here instead of data, raw data, right? Raw data consists of measurements of some attribute on a collection of individuals, right? Here, this data set, these two data sets, I say these two data sets has raw data, the originally collected data. They are not analyzed, right? Here, this is a data set, right? And raw data set. This is also a raw data set. It is not analyzed, right? After doing some processing, we get in here it analyzed, but this is a raw data set, right? Raw data set. We say a data set or raw data set. In this raw data set, you can see several measurements are collected over some attribute, some object. Right? We first data set, we collect some measurements from A-level pass students. In the second data set, we have collected some measurements from university students, group of students, right? The measurements would have been made one of the following scales. You can see those measurements are coming from several scales. Several scales. There are mainly 4 scales of measurements. Those measurements, the pulse one measured in some way, right? Pulse 2 measured in some way. Weight measured, pulse 1 measured in some way. I can measure what is the pulse 1 value of the first student and record it. I can measure what is the pulse 2 value of the pulse 2 value of the first student and record it. Right? I can measure the height of the first student and measure it. I can record it. Right? Then ran, I can observe whether that student ran in place or did not run in place. Whether he is a male or female, he is a smoker or non-smoker. How we collect the data, how we get those measurements, and how the data collected, measured, we can divide this data into 4 scales. 4 scales, right? These 4 scales we named as nominal scale, nominal, ordinal scale, interval scale, and ratio scale. Right? Nominal, ordinal, interval, and ratio. We say how much information the numbers associated, right, with that factor contain, we get from these scales. And it increases from nominal scale to ratio scale. That means from the nominal scale data, we get very few information. Ordinal scale data, we can get more information than nominal scale. Interval or ratio scale, we can get more information than nominal, ordinal, and interval. Right? So when we go from top to down, the number of information we can get from this data are increases. So let's see what is the nominal scale data. What is the nominal scale? It says the classification, nominal or classification scale. We classify the data points on. Right? The measurements we obtain here is like in some qualitative nature. Right? Either numbers or symbols are used to classify those objects. If we use some numbers or some text values, those we use to classify. Right? For an example, gender of a person, smoking habit of a person. The data points are like this, right? Gender, gender of a person. If I collect the data, I can collect the data like for the first person is whether he's a male or female. The second person can be a male. The third person can be a female. Like this, suppose I collect the data from 4 persons, the fourth one also be a male. Like this, we have the data, right? Or I can record this data as gender. Instead of writing male, I write 1. Instead of female, I write 2. Right? This is another way of recording the data. Right? We call this gender of a person here, the data point are like in some qualitative nature. It represents some quality only, not the measurement. I cannot measure the gender. I can say whether he is a male or female, some qualitative in nature, right? This 1 and 2 values represent with the person is a student, is a male or female. Other than nothing. Nothing about these numerical figures, right? The symbol or categories have no logical order, have no relationship, and they are mutually exclusive, right? Here, when recording the data, the gender, in the data, I use 1 and 2 values, right? Can I, in the actual meaning of, when I go through the actual meaning of 1 and 2, right? We know that number 2 is greater than 1, right? Number 2 is greater than 1, according to these values. But what the meaning of this? According to the collected data, what this means now? In generally, we know 2 is greater than 1. 2 is a numeric number. 1 is a numeric number. 2 is greater than 1. Now, what the meaning for this situation here? 2 means what? Here I use 2 for female, 1 for male. So 2 means what? Female. 1 means male. Now, what can you say about this relation? Can I say not the number of female, right? Not the number of female, just this qualitative value, female category greater than male category. Is what you can say, is this correct? Female greater than male? Or instead of instead of using 1 and 2, I can record the data for the data for the factor gender. For the males, I can use 4. So second person also male. I know 4 means male, right? Then for the female, I use 2. To record the male, I use 4. Right now, I use 4 and 2 values. Then I know that the 4 greater than 2. 4 means male, greater than female. Is this 2 correct? Can we say like this? Female greater than male or male greater than female? This is completely wrong, right? These are numerical figures, but I use those numerical codings to present some text values, to denote some text values, male and female. There is no numerical meaning for 2 and 1 and 4 here, right? It just represents some text figure. There is no logical order, right? So the only comparison that can be made between the variable values are equality and inequality, like male category and the female category. I cannot say the female category is greater than male category. right? So data on here we can say that the data in nominal scale, the data measured in this variable, this factor gender is nominal, right? The variable smoking habit, if it is recorded as smokers and non-smokers, like this text or numeric figures, it's a nominal scale measurement. Right? Data values can be classified into categories only. These categories has no specific ordering. These categories I cannot order. I cannot order these categories. Right? Then the next one is the ordinal scale. That means ordinal scale factors, ordinal scale factors, for an example, education qualification, customer satisfaction regarding a certain food. Right? How the data comes from? If I measure the education qualification regarding several employees, the first employee studied up to O level. The second employee studied up to again O level. The third employee can be studied up to A level. Like this way, I have these categories: O level, A level, D3, like that. Or rather than using O level, A level, I can use when entering the data to the software. It is easy to use some numeric figures, or you can use some capital English letters also. Right? So instead of O level, I use 3, and for denote A level, I use 2. Right? Suppose the fourth employee is passed up to A level. So again, to present that data point, I can use 2. Right? So just categories only. The data like all the features it has like in nominal measures, but another important point is here we can rank those categories. We can rank those categories, right? I can say that O level category is less than A level, right? A level is less than D3. Like this way, I can category, I can rank, I can order, right? Comparisons of greater and less can be made among these categories. Right? If we consider the data like if you collect the measurements regarding the customer satisfaction, right? The customer satisfaction regarding some food, how we collect it, like is the customer can say very good, good, or neutral, bad, or very bad. Like these options, one of these options can comes as the data point. So we can order only some categories, data like some categories, but the difference between the nominal scale, gender, smoking habit, like these factors, and the ordinal scale is we can order these categories. Right? We can order, but numeric values also has not specific numeric meaning. Right? But we can order. Right? Here, if I can use right here, I can say the 2 is greater than 3 because 2 represent 2 is greater than 3. I can say this because here 2 means A level category, 3 means O level category. We can rank it. Another data type is interval scale, and the last one is the ratio scale. Right? First talked about the interval scale data. Let's talk about ratio scale. Right? Most of the data points comes from ratio scale. It has all the features of nominal data, ordinal data, interval data. All the features for all 3 categories features has the ratio scale. right? And in the ratio scale, these properties also there. We can talk about meaningful ratios, right? Operations like multiplication, division, all these are meaningful. Data collected under, for an example, factors like blood pressure, weight, student marks, Z-score values. All are, we can say that the ratio scale measurements, right? For an example, if I collect the data like here, this weight, right? Like this data, weight, height, pulse 1, pulse 2, these are some measurements. For these measurements, I can talk about the ratios. I can talk about some numerical calculations. Right? Suppose I collect the weight of the 5 students, weight of 5 persons. Right? I get the measurement. The first person weight is 40 kilogram. The second person weight is 80 kilogram. The third person weight is 35 kilogram. The fourth person weight is 43 kilogram, right? Fifth one is 60 kilogram. Like this way, I collect the weights of 5 individuals. We say these data are ratio scale data, because I can talk about the meaningful ratios also, right? Here, if we compare the first person and the second person, I can say that the second person weight is 80 kilogram, first person weight is 40. Second one is 2 times weight than the first one. I can talk about some ratios. These are not like the male, female, O level, A level, degree, like those are not like categories. Those are some numerical, this 40, this numerical value has its numerical meaning. If we say 40 and 80, if we compare these two values, I know that 40 greater than 80 greater than 40. It's correct. This data point has its numerical meaning. Because of that, I can calculate the ratios also. I can calculate the ratio between the weight of second person to the weight of first person. The ratio is 80 to 40. I can calculate. It's meaningful. And also 0 point is, right, 0 point is meaningful. The difference between the ratio scale and the interval scale is the 0 point is arbitrary, it is relative in the interval scale, but in the ratio scale data, the 0 point is meaningful. If I say 0 kilogram, 1 person, suppose for the 6 person, weight is 0 kilogram. This cannot happen. 0 means weight is 0, nothing there. There is no person here. Right? It has its meaningful 0. Meaningful 0 point. 0 point is well defined. But we say in the ratio scale, interval scale data, the 0 point is arbitrary. 0 point is not meaningful. Okay? For an example, body temperature. Suppose I collect the data regarding the body temperature of several persons, body temperature data using centigrades, right? The 0 point is meaningful. 0 point is not meaningful, it's arbitrary. right? And also the ratios between the numbers are not meaningful. Ratios between the numbers are not meaningful. Suppose in a one place, city A, but temperature is 30 centigrade. In city B, I have another data point. In the city B, temperature is 60 centigrade. Right? I know that 60 is 2 times 30. But I cannot say that place B is 2 times warmer than place A. It's not meaningful. That ratio is not meaningful because it is relative to the, we can talk about these points relative to the zero. Right? So the 0 point is not meaningful here. Right? If we say in some place, in place D, air temperature is centigrade 0. It says what it says. 0 means here, 0 means in ratio scale, body weight 0 kilogram means nothing there. There is no person, right? But here 0 means no temperature. It's not the meaning like no temperature. The existing temperature is 0. The existing temperature is 0, right? It doesn't mean that nothing in the body temperature or temperature in a place, it doesn't mean nothing. It says existing temperature is 0, right? So these are the 4 scales of measurements. And before going to this activity 1, right, we can get a break also. Before going to the activity 1, could you please tell me right in this data set, right? Could you again go through? I will give you 2 minutes, right? Go through these 2 data sets and tell me these factors. What are the scales of measurements of the data in these factors in the 2 data sets? That is, we have student number, set score, gender, district, school type, average income, pulse 1, pulse 2, RAN, smoke, activity, right? Go through all these factors and the data point it contains and tell me what are the scales of measurements that these data are collected. Whether the data are nominal scale, interval scale, ratio, like that. Please get 2 minutes and try. Right, what can you say? In the first data set, the scale of measurement for gender is what? Scale of measurement for gender. Whether it is nominal or ordinal or interval or ratio, gender. Gender has the data. When we look at the data in the gender, is recorded. The data points has only two categories, males or females. And I cannot order these categories. So then gender is what is the scales of measurement? Is it ordinal or nominal? Right, one answer in the chat box, let's see. Right, it's nominal. It's not, right? So gender, it contains nominal scale data. Nominal. Then what about the district? Please try to understand, right? This is very important because the other things depends on the knowledge about the variable types. Other things you have to learn, like getting graphical outputs and data analysis. To do those things, you want to know about these things well. District. When you look at the data in the district column, district factor, right? Data collected as Gampaha, Kandy, Kalutara, Matha, Colombo, like the district. Just the district only. Some several categories according to data collected as several categories. I cannot order these categories. So district also nominal scale. Right? So thank you very much for your answers, right? Those are correct, nominal. Then the school type. School type. It's nominal or ordinal. You can see it has only categories. School type can be central or national. Central or national. And it's nominal or ordinal.
Nominal. Hello? Right. It's also nominal, right? It's nominal, nominal scale data, right? This is also nominal. Then what about the average monthly income? And ISET score, the data in average monthly income and ISET score. Average monthly income and ISET score, like for the first student, average monthly income 65,000. Second student 87. Data recorded as some numeric figure. And those numeric figures has their numerical meaning. Right? You can calculate the ISET score also 1.07, 1.32, 0.99, some numerical figures. Those have some numerical meaning. Right? You can say that the the first student average monthly income is lower than the second student average monthly income. Right? And we can say that this student has the highest average monthly income. So we can compare those categories. So it is a ratio scale data. Here is data in ratio scale. And the Z score also ratio. Right, this also ratio. Right, then the student number, I'm not going to talk about the student number, right? So tell me in the second data set, right? Now pulse 1, pulse 2, height, weight, all are ratio scale, right? All these variables, pulse 1, pulse 2, height and weight, all these are ratio scale. Recorded as some numeric figures, and those numeric figures has their numerical meaning. Right? Then what about these variables? Ran, smoke, sex, right? I said you in ran, 1 and 2 means one ran in place, ran in place 1 minute. 2 means did not run. Right? Then smoke, suppose 1 means smoke, yes, regularly, 2 means do not smoke regularly. And the factor sex, we have 1 and 2. Suppose 1 means male and the 2 means female. Right. Now, what can you say about these 3 variables? What is the scale of measurements of the data? These 1 and 2 values here. Do they have their numerical meaning? Think about like that, right? Just we have some categories and let's see the answer, right? The data. Right? Here, this ran, smoke, and zits are nominal scale, not ordinal, right? Nominal, just categories only. I cannot I cannot say male greater than female, yes greater than no, right? I cannot say here 2 greater than 1, but I cannot say no greater than yes. It is not meaningful. 2 represent no category, 1 represent yes category, right? But the activity, right? The last one, this column contains the data for the activity. This is ordinal scale. Ordinal scale, this contains ordinal scale measurements, right? Because the data here like 1, 2, 3, 1, 2, 3 means lot, moderate and low, right? The data recorded as categories, those has some numerical meaning, right? Any questions? Any questions? Let's get a 10 minutes break. So, right now the time is 10:15. Let's get a 15 minutes break, right? Let's get a 15 minutes break and continue the lesson, right? Please join again at, I will start the lesson again 10:30, right? 10:30. So you can go through this activity 1, right? This activity is in your course manual. Please download it and try to answer, try to check. For each of these measures listed, determine what scales of measurements are these, right? For these, if you consider the measurements for this list, right? What are the scales of measurements, whether it is nominal, ordinal, interval, or ratio, right? Please try to complete this one and get get a break, and please join again 10:30. I will start again at 10:30, right? Right, let's start now. Right, this activity 1. What are the scales of measurements if you have collect the data for these this list? That is, for an example, the first one, the religious group that one affiliates with, religious group of a person, the time it takes to complete a checking task, the time, right? If we talked about the time need to complete some task, how the measurements comes from, the score on the 35 items, right? And the rank of a person's salary with the company, the rank of person's salary within the company, whether he has some rank, as some rank, the data collected, that is the person's salary is a high rank or middle rank or low rank, as the way we can collect the data, right? Question number 9, the heart rate of a patient participant. How we measure the data? What is the heart rate of the participants? One's ice cream preference, 11th one, one's ice cream preference. Whether how we then, when think about how we collect the data for it, whether he likes to this ice cream or not, or we can collect the data like whether according to some scale, right? You can think how we collect the data, temperature measurement of different region, ethnic group of a country, right? So what are the scales of measurements, right? For the first one, the religious group, whether right, what is the religious group of a person? We collect the data, but in some categories, right? Hindus, Buddhist, Catholics, like that. Some categories only, right? According to some categories only, and I cannot order these categories. I cannot say that the Hindu category is greater than Catholic. I cannot say like that. It's not it doesn't mean the number of Hindus or number of Catholics, right? Just I am talking about the category, right? Hindu or Muslim, Hindu or Muslim, right? Islam, right? Like just two religious, just the religious group. So this is a nominal scale. The item it takes to complete a check-in task, time it takes to complete a check-in, we record some time, whether it takes 10 minutes or 15 minutes or 17 minutes, like that, we collect the data, right? So it's a ratio scale. Score on 35 item. Out of 35, what's the score, right? It's ratio. The rank of the person's salary. According to the person's salary, we have some rank. Whether he has, according to his salary, he's obtained high salary or middle scale salary, right? Or low scale salary, like ranking. So it's an ordinal, right? So like this way, you can identify the other, for the other questions, so you can identify the scales of measurements. Any questions? Can you complete it? Okay, please complete this one, right? And if you have any questions, you can send me an email.
Right, this is my email address. Right, manjula@sjp.ac.lk. Right, when you are doing your homeworks, activities, if you have any questions, you can send me an email or you can call me. Right, you can put me a WhatsApp message also. This is my mobile numbers, notes 7763679555. Right, so try to do these things, right? Otherwise you cannot understand. Please try to complete these activities and go through your manual also, read it. Now let's go to the term variable, right? Up to this point, when I am talking about the information, I talked about use the name factor, gender factor, Z-score factor, right? Actually, those are in statistics we called as the factors also, but the real name is the variable. Those are variables, right? We collected data from some objects relevant to several variables, related to several variables. Variables are measurable characteristics of things. What are the things? Those can be persons, some objects. We can collect the data from students. We can collect the data from some patients. We can collect the data from tomato plants. You can collect the data from the forest in the trees regarding the trees in the forest. Regarding the trees in the forest, right? So we can collect the data from any objects. Those data we call, the data we collected first under several variables. The variable represents some characteristics, right? Those vary within a group of such thing. Those vary within a group of such thing. We call those as variables. These are the examples for variable: weight, height, pulse rate, gender, education, qualification. All these we called as the variables, right? Here in our first data set, I have this column: student number, Z-score, gender, district, school type, average monthly income, right? Here I say all these are variables. These are some characteristic. Z-score, gender, district, average monthly income are some characteristics, right? According to the definition, those are some characteristics measured under several students, measured for several group of students. Those can vary. Those are variables. It can take different values. If we say the Z-score is a variable, right? Gender is a variable. It can take different values, male and female only. Z-score is a variable. It can take different values. Z-score can vary in between some two different values. Average monthly income is a variable. It can vary in between two different values. For this student group, suppose that the average monthly income can vary in between 10,000 to 150,000. Right? So it can take any value. It can take any value in between these two defined points according to your data collection. Right? So all these are variables. Here in this data set, I have 5 variables. So what are the characteristics? See, if we are studying a group of university students in the example, variable can be a weight. It is measurable. Weight of a student, measurable. It varies from student to student. Gender is also variable. I cannot measure it, but I cannot record what's the gender type as some category. Right? So, according to the characteristic or attribute of that statistical unit of interest, with the values that comes from, those values can be numeric or non-numeric. That is the variable. For the variable, we can collect the data, right? According to the data, whether the data numeric or non-numeric, we call that variable as a quantitative variable or qualitative variable. Right? If we say the gender, right? That is the two types of variables. Qualitative the variables, mainly the variables can be divided into two parts. Qualitative variable and the quantitative variable. Variable is some characteristics related to our objects, right? It can take different values. Variable can be a qualitative variable or quantitative variable. For an example, these are some qualitative variables. Those variables represent some quality only. Gender of the person, eye color, type of automobile on for the group of persons. So it represents some qualitative characteristic, qualitative data. So those variables we called as qualitative variables. Quantitative variables mean when the characteristic being studied can be reported numerically. If we talked about the lifetime of a battery, we can collect the data numerically. Age of a person, age of a student, number of children in a family. We can collect whether the number of children in a family is 0, 1, 2, 3, 4, like that. I can collect the data. So those type of variables, these are we called as, all these are variables according to this classification. These variables are qualitative variables. These are quantitative variables. Right? Again, the quantitative variables, that the variable represents some quantities. Again, we can divide those quantities into two cases, discrete variables and continuous variables. These are the examples. Please read these two. What are discrete variables and try to understand what is the difference between the given example, the difference between the discrete and continuous variables. Please read and understand. Can you see the difference? Discrete variable and continuous variable. We say weight of a student is a continuous variable. It's a quantitative variable and continuous variable. Earlier we discussed about the scales of measurements, right? That is how these measurements are obtained. According to how the measurements are obtained, these variables we can divide into 4 scales: nominal, ordinal, interval, and ratio. Now I am talking about the variable types. How we define this variable, that is, it's a qualitative variable or quantitative variable. Again, if it is a quantitative one, whether it is a discrete variable or continuous variable. Right? We say weight of a student is a continuous variable. That means observation of this type of variable can assume any value within a specific range. If I measure weight of a student in a certain class, right, Suppose the class has 50 number of students and I collect the data regarding their weight, right? The weight can be vary within some two points like minimum value and the maximum value, right? Two defined point. There is a minimum weight. Suppose the weight minimum value 20 kilogram to maximum weight of a student and go up to 35 kilogram. So if I consider this variable weight of a student in the class, it can take any value. It can take any value between these two. So we say weight of a student is a continuous variable. If we consider the marks of a student, student marks. If we consider marks of a student also, marks can be vary from 0 to 100. It can take any value. Marks of the student can be 0 or 100. It can be 50, 55, and any value within two defined values within a specific range. If we consider height of a tree, it can be any value defined to define limits. It's a continuous variable. But what's a discrete variable? The example is the number of bedrooms in a house. Let's say it's a discrete variable. If I say number of bedrooms in a house, the data can be number of bedrooms can be 1, number of bedrooms can be 2, 3, 4. Suppose it can go up to 6, 5, or 6. Only discrete data points. Right? If I collect the data for the number of bedrooms in a house, like variable name number of bedrooms in a house, right? For the first house, number of bedrooms can be 2. For the second house, number of bedrooms can be 1. For the third house, number of bedrooms can be 6. Like this, I can collect, suppose I have 100 number of house, I can collect the data. These are discrete values, not like the continuous. Can you give me another example for discrete variable? Think about another example for a discrete variable. Number of children in a family. It's a discrete one. Can be 0, 1, 2, 3, 4, 5, 6, 7, like that. Discrete. It's a discrete variable, right? So when we look at the data set, right, according to the type of the variables, we can divide the variable. We all know that I collect the data related to some objects for some variables. How the data are measured? Data can be recorded as some numeric figures or text figures. Here, data recorded as text, data in the gender data recorded as text, district data recorded as text, school type we have text data, but monthly income and asset score we have numeric data, right? How the measurements are obtained? We can divide it into 4 categories, like nominal scale variable, in ratio scale variable, interval scale variable, and ratio scale, nominal, ordinal, interval, and ratio scale variable, right? Then according to the types of the variable types, we can identify mainly some variables are qualitative in nature. Some variables are quantitative in nature. Some variables are discrete. Some variables are continuous. Right? Now tell me, what are the qualitative variables in this data set?
What are the qualitative and quantitative variables in this data set? This simple data set. Which variable represents some qualities? Which variable represents some quantities? Do you have questions?
Madam,
Hello?
Madam, is Z-core is a continuous variable?
Yes, it's continuous. But first tell me whether it is a qualitative or quantitative. Is it scope? Is a quantitative variable or qualitative variable?
It's a quantitative.
It's a quantitative, right? Is it score is a quantitative variable and she's correct, right? This is a quantitative variable, quantitative. Right? And we know that a quantitative variable can be divided into two categories, discrete or continuous. Again, it is a quantitative and it's a continuous. Right? This is continuous. Now tell me the second one, gender. It is a qualitative or quantitative? Whether it represents the
Qualitative,
data.
madam.
It's a
Qualitative.
qualitative. It represents some quality, whether the person is a female or male, right? It's a qualitative variable. This is a qualitative variable, right? This represents some quality only, qualitative. District is again, it's a qualitative variable. School type represents some quality, whether the school is a central school or national school. So just a quality only, right? So it's a qualitative variable. Then average monthly income. But the definition of quantitative means it reports some
Qualitative
new.
data.
It's a quantitative data, right? It's a quantitative. This is a quantitative variable. Then what about the discrete or continuous? This is a quantitative and discrete or continuous. This average monthly income is discrete or continuous. It take discrete values or continuous values.
Is maybe discrete.
Right. How you see the data, you can see it's a discrete. Can't we say it's continuous? Why can't you say it is continuous? Think about the definition, right? How you define a quantitative variable. How I define a quantitative, continuous variable. How we define a continuous variable? That variable can assume any value within a specific range. It can assume any value within a specific range, right? Then what do you think? Whether it is continuous or discrete. You can see some discrete figures because when we enter in the data, right? When we are entering the data, I can round these values. Here Z score is in decimal places, into 4 decimal places, but average monthly income into 0 decimal places. So how these values, you can see these values, when you see this value, you can say those are just discrete figures. But this is not a discrete variable, this is continuous. Did you get the point? This is continuous. Why this is continuous?
right? According to the definition, right? Here, according to 2, if we think about the monthly income, average monthly income of a family of certain group, I can say that it can be vary it can take any value in between 2 defined points, right? It can vary from 10,000 to 100,050, right? It can take any value in between, right? That's 150,000 to 10,000. Any value, but when we record the data, we can see discrete figures, but when we go to the actual meaning of the variable, it's continuous, right? So in statistics, we say when we are analyzing the data, right? When you give a data set like this, always the data set, we find the data set in this format, as Excel sheet or Minitab worksheet or Word document as a table. You will get this type of a data set with the variable names, right? But the variables name are very short, right? Because when entering the data, we have to use some methods to enter the data easily, right? When we talked about the data set means a very large set. It contains 1,000 or 10,000 number of data points. Sometimes we will get large data sets, right? When you are doing the survey, sometimes you have to collect the data by doing a survey covering 100 number of employees. Then you have to, one by one, you have to enter their information, the variables collected to the Excel sheet and create this type of a table, this type of a data set, right? So when entering the data, we use simple names like that. But you should know, before analyzing the data, you should know the clear meaning of these titles. What this school type says, what the set score says, in which unit it has measured, right? In the pulse data set, you want to know here, I said you, there is no any information here regarding what is pulse 1, what is pulse 2, what is RAN, the simple names. But I told you the story behind collecting this data set. Now you know the story, right? So that story, definitely when before analyzing the data, you want to know about why these data are collected, from whom these data are collected, and what this variable means. What is the meaning of RAN? What is the meaning of smokes? What is the meaning of activity? How it has measured? Activities measured in three categories, like that. Before analyzing the data, right, with the data set, you need some description. We should have some description before analyzing, right? Otherwise, we cannot perform a good analysis. Right. Now, any questions regarding the variable types? Do you have any questions to ask here regarding this exercise 2.1? Any other questions? I said you there are 5 variables only. Right? Don't you have another question related to the columns here? Regarding the columns, right here I have 5 columns now. But I do not say, right? I do not say this is a variable. This is, what do you think? Student number. It is not a variable, right? It is not a variable because for all other 5 factors are variable. Some characteristics, set score, gender, district, monthly income, school time, all are some characteristic measured regarding the students, right? But student number is the student number. It can vary, but it is not a variable. It's not the meaning of variable. It just shows what is the student index number, what is the student registration number. When collecting this data, they have collected the student number also. Because of that, they entered it for to get some information. They have recorded that column, but it is not a variable, right? This is not the variable. So we are not, that means we cannot analyze this. What's the meaning, right? For all these variables, right? Here, it is meaningful to talk about the, out of these, here, 1, 2, 3, 4, 5, 6, and 10 students. Out of 10 students, how many females are there? Out of 10 students, how many males are there? It is meaningful to talk about it. How many students are studied at national schools? How many students are from Kandy district? It's meaningful to talk. So I can talk about what is the highest value of the average monthly income. What is the average Z score value? They can talk, but I cannot talk about the average value of the student number. I cannot do any analysis for this, right? This is just only for the data recording purpose. Right, got it? Any questions? Right? So this is a very, very important subject, right, in your working place. If you know handling, doing some data analysis, that means you are very important for your place, right, your office. Because today, all the firms are working with the data, because they collect data and they want to analyze the collected data to get some decision, right? Or many firms, many high-level firms in the country, not in the country, in the world, they use data, right? They collect data regularly, and they analyze those data to come to the decisions, right? You know that in the garment factories like MAs, right? They have their research analysis section also, data analysis, right? They are collecting their data daily, right? Right. Then next we can go to another topic, right? Still we talked about the data, and now you know what is a data set and how the data comes from. Some data like numeric, some data are text. And now you know the data can be divided into several scales of measurement, how they are measured. And we have the variables. The variable means the characteristics collected over some objects. Those are variables. Variable mean it can take different values, right? And variable mainly divided into 2 parts, qualitative, quantitative, and quantitative again we can divide into 2 parts, discrete and continuous. Right? Now we can talk about another title like population and sample. What is a population and what is a sample? Right? Please read these 2 slides. go through these two slides I got from this your course manual, right? And read this. What is a population and what is a sample? And go through this figure also. Try to identify what I am going to talk with here. What is a population and what is a sample? Please get 1 minute and go through this. Right, okay, let's see what is population and a sample. Right? In data collection process, we collect those information. We collect several information like ESET score, gender, monthly income from certain objects, right, which possesses these characteristics under our study. That object, right, we collect the data, that means the object, the data we collect from several objects, different objects. The objects can be employees in a factory, the objects can be student in a class, objects can be undergraduate students in the first year undergraduates, objects can be a plant in a forest, right? Object can be a insect, a farm, a paddy field, right? It can be anything according to your research study. That means simply from whom we collect the data. From whom we collect the data, right? So here you can see in this figure, the population is a big one. Here I have a large group of individuals, right? The sample, that means from this whole set, I select a subset. I select a subset. Here you can see in the whole set population, I have different colors of persons, right? Pink color, green color, black color, blue color, right? Gray. I have different types of objects to collect the data. But what we do, I have the whole set, and again I have some representative sample, representative subset I get from this whole set. We call that representative subset as the sample. Sample. The whole set we called as the population, right? So this process, when getting a subset from the population, we called as the sampling. In statistics, this is a separate section, how we select this sample subset from representative sample from the population, right? So let's go to the definition. Population is the entire set of individuals or object of interest, right? And the population is a collection of elements about which we make to do some inference. I will explain the term inference, right? The important task for the researcher is to carefully and completely define the population before the study, right? In any research study, you should have a population. It should be clearly defined. You should know what is your population, right? Sometimes your population can be finite. Sometimes your population can be infinite, right? For an example, suppose this is the population is the population is the number of employees, right? For an example, my population is the number of employees in factory A. In a certain factory, total number of employees in factory A, right? So I want to collect the data from the employees from factory A. So the total number of employees in the factory is my population, right? Suppose another one, the total number of trees, in a certain forest B, in a certain forest, total number of trees, right? If sometimes I can count the total number of trees in the forest, sometimes it is difficult, right? If it is countable, we can say it is finite. If it is uncountable, we say it is infinite, right? The number of employees in the factory, suppose this factory contains 5,000 number of total employees, so it is a finite population. I know what is the total number of employees in the factory, right? So then what is the sample and why it is important? Right? Suppose I have this research problem, right? My objective is, suppose my objective is I have this research study. I have a certain research study, and related to this research study, I have one objective. There may be several objectives. My main objective is to identify the number of disease trees in the forest B, right? I want to identify the number of disease trees in the forest B. Number of disease trees. If we consider a certain forest, right? Suppose I can count the total number of trees in the forest. There are 10,000 number of total trees in the forest. I use capital N letter to denote the total number of trees in the forest, right? Some trees are good, some trees are diseased trees, right? Now my research, I want to identify the percentage of diseased trees or number of diseased trees in the forest. So how do we do this experiment, right? Can you go to the forest and check each and every tree? There are 10,000 number of trees in the forest. Can you check? One thing is you have to check the 10,000 number of trees and get the count of diseased trees. If you go like that, think about how you do it. Is it practical? Can you go over the 10,000 number of trees? How much time you have to spend? How much money you have to spend for that task? Right? How many assistants you need to you need to get the help of several assistants, how many assistants you need to collect this information. If you are going to collect the data, right, what's my data here, whether the tree is a defective one or not, disease one or not, right? To collect that data, you have to do big, it's a big task, right? Sometimes it is not practical. You cannot do it practically. Then what we do, right, in our research studies, what we do, normally we select a representative sample, right? This term is very important. We select a representative sample from the population. We take a representative sample from the population, right? We take some subset which represent the whole population. Suppose I select 200 trees from the forest, right? I'm not going to say how I select these 200 out of 10,000, right? Because it is not in your, not in this unit, right? It's we will talk about it. You will learn it, and if you have any other statistical units in third year, you can learn it under sampling methods. Anyhow, see, think I select 200 trees from the forest, and I collect the data from these 200. It's my sample. The sample size shows simple n. Right? I collect the data from this, not the population of the forest. Right? I collect the data from the sample. So what is a sample? A portion or part of the population of interest is not, it must be a representative one of your population. And what is meant by elements? Elements are these entities or objects which we collect the data. Right? So this is the meaning of the population and the sample. So when collecting this, these two data sets also, right? Normally when collecting the data, most of the time in practical situation, be based on a sample of student, right? From the A-level pass students, if I want to talk about the A-level pass students in Colombo district, how many students are there? Right? Practically, I cannot reach each and every student in Colombo district who have passed A-levels. Suppose it's last year, right? So you have to clearly define your problem. What is your population? The A-level pass students in last year or A-level pass students in year 2023? You have to clearly define it, and you have to identify your population, right? And if it is not possible to collect the data from a population, most of the time actually it is not possible. What we do, we select a representative sample. Here I collect the data from only 10 students, right? Here in the university, there are no, the data set here, this data set totally, the collected data set contain 92 number of data points. The sample size is 92, but the university has like 1,000 number of students. The population size is 1,000, but I collect the data from only 92. It's my sample. So these are actually sample data sets, right? We analyze those data, right? Then you now know that, get this idea, that is, I collect the data from the sample, right? I collect the data from this sample. I collect how many number of trees, percentage of diseased trees in this sample of 200 trees selected from this forest, right? So, but this is, I collect the data from here and I analyze this data, right? I do the data analysis based on this sample data. and analyze the sample data, right? We analyze, we get the graphs and tables, analyze sample data. Right? We get the graph, tables, and several things, and we talked about how my sample like this. Right? What are the average heights of the trees in the sample? What are the how percentage of defective trees in the sample? But according to my research problem, actually I want to talk about my population. I want to give the conclusion. Right? I want to give the conclusion regarding this population. I want to give the conclusion regarding this population. I have no actual data regarding population, but I have only data collected only from a sample. So we analyze the sample data and we talked about, we give the conclusion regarding the population. We call this process as statistical inference. Statistical inference, right? From sample to population. That means we called it as the statistical inference. Earlier I said you in this unit you have to talk about, you need to learn hypothesis testing. That means I have some hypothetical statements. Suppose I have a hypothesis like, right, regarding this population. I have a hypothesis like, when we are writing the hypothesis, we write it like this: H naught, the percentage of proportion of defective trees. In notation, I write this, right? Capital P means the proportion of defective trees in this forest. Proportion of diseased trees in this forest is 80%. I have this hypothetical statement regarding the population of trees in the forest. But as a researcher, I don't know whether it is true or correct, right? Regarding the population, this is the population proportion. To come to some conclusion, for that, what we do in statistics, we select a sample of trees from this forest and we collect the data, like whether it's a diseased tree or not, and we calculate. Now using the collected data, you can calculate the proportion of diseased trees in the sample. Out of 200, what is the proportion? Right? Suppose out of 200 trees, in the sample, 150 are diseased trees. Then I know the proportion of diseased trees in the sample, right? So from this one, using this collected information, using the sample proportion, I can talk about whether the population proportion of diseased trees is 80% or not. We call it as statistical inference. There are several methods under statistical inference to talk about it, right? So that is the relation between the population and sample. And what we are doing in statistics, mainly we collect the data and we analyze those data. Normally we collect the data using a sample. After analyzing the data, we are going to do inferences about the population, right? And we analyze this data. You can do some, in the analysis also, there are two parts, like the descriptive analysis. That's just we describe the data, getting some plots and tables, I describe, right? And also there are several advanced analysis also, like regression analysis, we can talk about later. Right, got it? Any questions? Right, no questions? Right, please go through these, right? Go through this and read your manual. Right. Next, in lecture note number 2, we need to talk about there are several limitations in statistics and the two branches of the statistics. What are the two branches of the statistics? And after that, we can go to some data presentation, descriptive analysis, that is how we summarize the data, like how we create this type of tables and how we, like you have these like this raw data, how we summarize, right? Here, there are 92 number of data points. If I want to get some summary like average, how we do it, right? How we construct these tables and how we draw this type of diagrams, like this we called as a bar diagram, right? Bar chart, and these are like pie charts. What are the importance of this diagram? This is like a histogram. Right? These are called the like describing the data. Here, the heights of the students, right? Suppose you have this data. These are the actual data points of heights. Right? So here, by looking at this data, right, there are 100 data points here. I cannot get any idea, right? Since this is in ascending order, I can say the highest value is 74 and the lowest value is 60. But how I took the average, the variability of this data, right? By keeping the data as this way, as the raw data, you cannot do anything. You have to analyze it, right? Here, using this graph graphically summarize how the heights vary. It's symmetrically distributed, right? So now we are going to talk about this type of data presentation. Right. Now, please go through this slide, limitations of statistics. Read what are the limitations. There are several limitations of statistics, right? Because most of the time we based on the sample data, right? And this sample, we say it should be a well-represented one of your population, because we analyze it and talked about the population, do the inference regarding population. If your sample is not a good one, what will happen? You will give wrong conclusions. You will do wrong inferences, right? So please go through these few points. What are the limitations? Right, what are the limitations of statistics? Statistics with wide applications, and there are several important limitations are here. Like the statistics is not suited to study of qualitative data, right? Not some like some qualitative measurements I cannot analyze. Qualitative measurements means like this type of data. Now, when collecting the data, if I collect what's your gender, right? Gender is a variable, it's a qualitative variable. I can analyze it. Percentage of males and females, like that I can analyze, I can draw some graph. But if I collect the data like this, what are the essential characteristics a leader should have? What are the essential characteristics of a leader? Right? Then if I ask this type of a question from a group of students, group of people, what are the essential characteristics of a leader. That means I will give some space to write. He can write anything. He can write several statements mentioning what he has think about this, what he thinks as the essential characteristic should have for a leader. How we analyze those data, right? Normally, those type of data I cannot analyze, I cannot tabulate. We cannot do graphs for those type of paragraphs like answers, right? So when collecting the data also in the questionnaires, we try to avoid these type of questions because those are very difficult to analyze. Just what you can do is you can read what are the answers, what are the responses given for this question, and you can give some summary. By summarizing their responses, you can write some discussion, right? So it's one limitation. And it does not study individual. In statistics, if I say average weight of a student in a certain class is 45 kilogram, it doesn't mean that each and every student weight is 45. If we consider all the students, the average one is 45. It doesn't mean that all the students are 45, right? And the statistical laws are not exact. There are several statistical laws, but always we deal with some uncertainty. So we cannot say that in mathematics there are some models, definite models, but not in statistics. We always work with some error term. Right? If we give some conclusion, there may be some chance of that conclusion is a wrong one. Because I give the conclusion regarding the population based on a sample. Right? I collect the data. When collecting the data also, several errors can happen. I cannot control some errors. Measurement errors I cannot control in the data collection process. Right? So we cannot say these are exactly true. And sometimes statistics, how the person do statistical analysis, how they report it, the reported value will give some wrong information to the society. Right? For an example, this example says, suppose in a certain newspaper, it says that the number of people like to toothpaste A is 7,500. Right? In the city, there are 7,500 people like to toothpaste A. This is totally, while looking at this figure, if you say this is a high value, how you say it? Can you say this is a low value? What's the reason? What's the reason? Why I cannot say that by looking at this value, why I cannot say that majority of the people like toothpaste A or not? Why I cannot say like this? Here, this value gives some wrong understanding. Some people can think this is a high value. The majority of the people like toothpaste A. Some people can think this is a low value. Why is that? Why I cannot get some decision regarding the persons who like to the toothpaste A by looking at this type of a statement? What's the reason? What do you think? What do you think? There is a problem here. In reporting this statement, there is a problem. There is a missing point here. right? Here for an example, for the today's lesson, say I can say the average, right? The number of student participated student is 80, right? 80. By the participants are 80. By looking at this value, I can satisfy because I know that there are 110 or 120 in your batch. Out of 120, 80 are present. Right? I know the total. If I don't know the total, I cannot say I satisfied about your participation or not. I cannot say here like this. It says the people like toothpaste is 7,500. Out of how many peoples? Out of the total, what's the total number of people in the city? Right? If it is the total is a 1 lakh, this is a very small amount. If the total number of people in the city is 10,000, this is a big amount. So this is actually misleading statement, right? Because without saying the total, you cannot get a clear picture like what this says. Is it clear? Any questions? So there are several limitations, right? When you go through the textbooks in statistics, you can find a lot of examples. Right. Now we are going to talk about the descriptive statistics mainly, right? And descriptive statistics is one branch of statistics. In statistics, mainly we can divide statistics into two branches like descriptive statistics and inferential statistics. In descriptive statistics, what we do, now we are going to talk about it, we just describe the data. We just describe our sample, right? If you have the population, you can describe it using some graphical outputs and using some tables, right? We summarize the data. But inferential statistics is a different one. That is, it provides to do some inferences about the population from the sample. From the sample, we draw some inferences. We draw some conclusions regarding the population. We call it as the inferential statistics. Right? In inferential statistics, we divide the inferential statistics into two cases, estimation and hypothesis testing. When we talked about this part, we can discuss these two. Now we are going to talk about descriptive statistics. In descriptive statistics, another name is exploratory data analysis. We called as simple terms, EDA, explanatory data analysis, right? Data used for descriptive purposes, we are not going to make any predictions, do inferences, just we talked about the collected sample, right? It's organizing and summarizing data. It's mean using some graphical and some computational method, tables or graphs, and some summary measures. We do these things under descriptive statistics. Right. Let's see first how we talked about the distribution. Right. Since the numerical and graphical approaches are complementing each other, it is wise to use both. Classification and summarization of data can be discussed under 4 groups. That is, we can summarize the data by drawing its distribution, by drawing some graphs, by calculating some measurements like central tendency, dispersion, right? we can calculate some average measures, variability. Other than that, we can draw the shape like the distribution. Like we can create some this type of tables. Like this we can summarize. So what's a distribution? Data distribution can be defined as an arrangement of the values, right, of a variable showing their observed or theoretical frequencies of occurrence. So that means now suppose you have 100 number of data points related to the student marks, right? Those 100 number of data points, from these data points, we can arrange those data points according to some way, according to some frequency distribution, according to some frequency table, right? What's a frequency distribution or frequency table? It's an arrangement of data by classes and the corresponding frequencies. Frequency means the number of times a category or some number of times that class contains that value. So you want to keep the following points in your mind for making classes or groups, right? When you are creating the frequency table, you should keep in mind these points. What are the points? Please read those points. The classes should be clearly defined and should not lead to any ambiguity, right? That means, for an example, I'm talking about this type of a table, right? Here, this table, these are called as the classes, right? So there are no any intersection between the classes, and the classes should be exhaustive. Each of the given values should be included into one of the class. That means if I have the raw data, when I have the raw data, I divide the raw data into several classes. And for each class, I consider each and every value and put those considering the number of frequencies for each class. Then each data point should falls into certain class, right? That means the classes should be exhaustive. The classes should be mutually exclusive. There should one data point cannot goes to two classes, right? The classes should be equal width. We are talking about the equal width classes. The principle, however, cannot be followed if the classes are varying with the different class frequencies will not be comparable. Right? We are talking about the if they are the class widths are different, we have to use another method. Intermediate classes should be avoided as far as possible since the create difficulty in analysis interpretation, that is open class intervals should be avoided. The number of classes should be too large or not too long. Right here, this is the frequency distribution. Frequency distribution, this is just a table, right? One column has class intervals and the other column has the frequencies. What this distribution shows you, the following table is a frequency distribution of the diameter of, right, diameter at dB, that's the dBH values recorded to the nearest centimeter, right? Diameter values, dBH values. Suppose DBH values are recorded from 80 teak trees. 80 trees, 1, 2, 3, 4, like 78, 79, 80. I have for 80 trees, I collected for 80 trees, I have collected the DBH values, right? For the first tree DBH value, and we here it is not given the raw data. Right. This is the example I got from your course manual, right? So suppose DBH value is 12 centimeter in centimeters. The second tree DBH value is 15 centimeter. Third tree DBH value is again 11 centimeter. 78, it's 16 centimeter. This is 22, right? This is 19. Like this way, suppose you have 80 number of data points in your data set, right? Now this is raw data. This is raw data. Now this raw data are summarized in some using some descriptive statistics. Here the raw data are summarized as a frequency distribution. Right? I divide the data, the whole data range. Suppose the DBH values vary from 11 to 25. I divide this whole data range into several classes like 11 to 13, 14 to 16, 17 to 19, 20 to 22, and 23 to 25. And after that, going through this raw data, I fill this frequency column. The first value 12. 12 belongs to this class interval. I put a mark. The second data point, second DBH value 15. It belongs to here. Third one again 11 belongs to here, right? The 78 one 16. 16 belongs to here. Like this way, I can put some mark and count what's the frequency, what's the number of trees falls in each DBH class, right? Finally, total is 80. Right? So this is we called as how we create this frequency distribution, and we call this as a frequency distribution. It's one side you have the classes, and the other side you have the frequencies, number of trees. Any questions? This is a tabular summary. Right? Now, by looking at the 80 number of raw data points, what do you think? Which gives this? What do you think here? Then now, what's the importance of this? No, this is we want why we draw these type of things, right? What's the importance, right? Here, what do you think? Can you get more information by looking at this raw data? Or can you get more information by looking at this summary, frequency distribution? What can you say? Which one gives you more information? Raw data or frequency distribution? What do you think? Right? Actually, when you have a large raw data set, you cannot, even though you cannot find the maximum highest or lowest value. If you have a large data set, like 1,000 number of data points, you cannot find it. But this is some summary, right? By looking at this, we can say the number of trees, out of the 80 number of trees in this sample, right? There are 20, nearly 20. 19 trees, DBH value vary from 20 centimeter to 25 in this range. 20 centimeter to 25 centimeter, there are 19. All others are from 11 to 19. So this all others out 80, the remaining all others 61 number of trees in between DBH values 11 to 19 centimeter, right? So here you can see it's a good information. How you say that type of information? By looking at this, right? But individually I cannot identify. Here it says in which there are 11 trees. The DBH value vary from 11 to 13, but I don't know individual values. I cannot see those individual values of these 11 trees from the frequency distribution. You can get that information from raw data, but it lost some information, but give more important information than the raw data. So these summaries are very important. Right? Any questions? Right? There is a request to explain that table again, right? Suppose now I said you that this table, directly you have given this table, right? This table we called as the frequency distribution, right? Here we can talk about how we create these class intervals and boundaries. Right now, this is the created table. Actually, this table is created. This table created using this type of raw data. Right? It gives the DBH values for 80 trees. 83 trees, the DBH values in a sample plot. Right? So the total number of trees here total is 80. Now, when we see the actual data set of this frequency distribution, it likes this. Right? You have the raw data. You have 80 number of trees. The first tree, what's the DBH value? Second tree, what's the DBH value? Third tree, what's the DBH value? Like they say, these are just some example data. Right? So, by looking at this data, it creates this frequency distribution. How it creates? It constructs these class intervals, right? Considering the range, how the data, the lowest value and the highest value. It creates several class intervals, 11 to 13, 14 to 16 for this data, right? Create. And after that, count how many number of trees DBH value in between 11 to 13, right? We start from 1 and read all the data, right? The first tree, DBH 12. So it belongs to this interval. The second tree DBH 15, it belongs to this interval. The third tree DBH 11, it belongs to this interval. Fourth tree, suppose the DBH value is 24, so it goes to this interval. Like this way, for this example, raw data, by reading all these 80 data points, you can fill these frequencies, this number of trees column. Number of trees column, right? This is how we construct this table, right? I will show you how we create this class interval. This is how, suppose you have the given class interval, then you need to simply fill this frequency column. Now I said you, this table gives more information. Right, this table, by looking at this table rather than looking at the raw data points, I can say that in the collected data, there are 4 trees. There are only 4 trees. The DBH value vary from 23 to 25. Right? And most of the trees, I can explain this way also, right? 50% of that is the half of the trees, 40, nearly 40, right? 50 trees, right? More than half, 50 trees, the DBH values vary from 14 to 19. The DBH value, the total, this 50 vary from 14 to 19, right? Only 11 number of trees, the DBH value vary from 11 to 13. Like this way, I can explain it, right? But when you have this raw data, it is difficult to say, find these things. But if you create a frequency distribution, by looking at this, we can discuss a lot of things. Like its distribution, we can discuss how we distribute, how the raw data, how the DBH values distribute. Right? Like if I draw the row using dash mark, right? See what's the distribution of this here? 11 trees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? 11 trees. Here 20 trees. Like 20 means 2 times like this. Right? There are 20 trees. There are 30 trees here. In the range 17 to 19, we have DBH value 17 to 19, 30 trees. DBH value 20 to 22, only 15, right? Here only 4. See how the distribution vary. Here we have the high, we have a high number of trees, and here we have low, very low values. The distribution vary, right? But we cannot say this type of distribution behave like this way. I cannot say by looking at the raw data. Definitely you have to summarize the raw data as this way. Otherwise you cannot say it. Right? But the disadvantage is, here one disadvantage, that is, although it says there are 4 trees, the DBH value in between 23 to 25. Right here, my data points are the DBH values. Right? This is the number of trees, the DBH value from 23 to 25. But I don't know these 4. These 4, the individual values of these 4, I can't say by looking at the frequency distribution. Sometimes all these 4 values can be 23. Sometimes all these values can be 25. Sometimes there are 223 values and 224 values. The frequency is 4. So I can't talk about the individual values, but just I can give some summary regarding how the DBH values are distributed. Right? Is it clear? Right, okay, right. Any other questions? Now let's see how these class intervals are created. Right, and class intervals and class limits. What are the class intervals and class limits? That is this one, this column. Right, how we create this column by looking at the raw data. There are several steps, right? Right, we can do it for this example. Class intervals, right? There are several terms like class limits, class boundaries, and class interval, right? The boundary figures of the classes here, 11 to 13, 14 to 16, like if you have this type of classes, a class interval that at least theoretically has either no upper class limit or no lower class limit indicated is called the open class interval. We say open class interval mean there is no upper limit or lower. These are class limits, right? Here, but if we write a class limit like 25 and over. 25 and over. 25 and over means 25 and over. Right? It's this next limit is not defined. So we say it's an open class interval. But these are closed. These are closed class intervals. Right? Then what are the class boundaries? The numbers indicated briefly by the exact numbers are called the class boundaries. Or another name for class boundaries is the true class limits. Right? Now 11 to 13 is the class limit. Right? 14 to 16 is the next class limit. 11 to 13, next 13, the next value is 14. 14, so it's 16. Right? Then if you can say next class limit like 16 to 18, I can write. Now, what are the class boundaries means? In 11 to 13 class limit, I say 10.5 to 13.5 is the class boundary, right? Then this class interval boundary is the 13.5 to 16.5. There is now you can see the upper boundary, this upper boundary of this class interval overlap with the lower boundary of the next higher interval. It is when we have some decimal point, right? Right. There is no gap here. Right? So the lower these are we called as the lower class boundary and upper class boundary. So in practice, the class boundaries are obtained. How we obtain these class boundaries? By adding the upper limit of one class interval to the lower limit of the next higher class interval and divide it by 2. So how I create this 13.5? I create this 13.5 by adding upper class limit of this interval with the lower class limit of the next interval. That is 13 plus 14 over 2. What is it? 27 over 2. That is 13.5. Right? So to find this, I have to add 16 and the next value and get the 16.5. Right? So the class interval means the difference between the lower and the upper limits is called the interval. Class interval size, right? Here, this should be the class interval size of the class interval. Right. So how we define the class interval size and the number of classes? To decide the number of classes and the class interval size, right? Class interval size and the number of classes, we have to use this one. So the appropriate number of classes may be decided according to this formula. Where n is the total number of observations. Simple n is the total number of observation. We define it by 2.5 over n to the power 1 over half. right? So suppose you have total number of data points 256, then the number of classes 2.5 by 256 1/4, right? So you will get 10 number of classes. That 10 number of classes mean in this table 10 number of classes you have. Now next the point is what's the width? What's the gap between these two? Right? So it is to decide the class interval size, that is C, how we get the maximum value in the data set and the minimum value in the data set, and we divide in the number of to decide the class, number of classes, right? So we get the class interval. So let's go to the let's go to this calculation. Right, any questions here? Now go through this example 2.2 and see the following shows the resting pulse rate of 92 number of students. Right, here you have given the pulse rate data for 92 number of students. When you count the number, you will get 92 data points here. The first student pulse rate 47, second student pulse rate 54, third student 54, like this, right? The 92 student 96, right? Now read these steps and I understand how we create this table, right? How we create the number of, we want to find the width of the class interval, right? And what's the, find the width of the class interval, and it says the number of classes is 5. 5 class intervals I want to create. So I want to find the width of the class interval. And how we create the width of the class interval, maximum value in the data set minus minimum value in the data set divided by the number of classes. That means maximum value of the data set minus minimum value means divide the number of classes. Maximum value minus minimum value means you want to create the range of the data. Range divided by the number of classes, right? So please go through this example and see how we create these values, this table, right? Any questions? Right, I think we can get a break, right? First you can try this, right? I will share another Zoom link and start the lesson at 1 p.m. Right now the time is 12:10. So during that lunch time break, you can try to do this question, right? Here for this data, you need to create a frequency table with 5 classes. With 5 classes, you know the classes are 5. You can find the maximum and minimum value in the data set and find the class width, and create the classes and the frequencies. By looking at data, you can try to create this table, right? And compare your answers with this table, right? With this table. First, you can create these 3 columns. These 3 columns only, classes and the frequencies, right? So go through the answer. You can go through the answer and try to understand. I will start again at 1 p.m. right? And also share new Zoom link for the evening session. I will share a new Zoom link, and please join from this Zoom link at 1 p.m. Right? Any questions? If you have any questions before leaving, please ask. Because I want to get the recording of this one also, and you can get your lunch break. Right, try to complete this one. After that, we can discuss and start to talk about the graphical representations. Right, then I'll stop the meeting. I want to get the recording, and please join with the new Zoom link at 1 p.m. Right, so thank you very much for joining.
Recording stop.
This graph bar chart, right? Try to present this table, information given in this table using a simple bar diagram. Right here, what you can do, just for the x-axis, you can get the categories, cereals, oil seeds, cotton, with the categories. And for the y-axis, from the y-axis, you can present the area, right? The area 309 and 85. And the area 1250, right? And 550, right? This the area used for cotton is 230, right? So by looking at rather than going through these numerical figures, right? Rather than going through numerical figures, anyone can get an idea about how these crop patterns, right? The area used under each crop pattern. We can get some idea, right? Or if one can use the percentage, area percentage out of the total area, percentage of area used under each category. You can plot it also, right? These graphical outputs are very important when you're analyzing the data. Now we are talking about how we describe the data, how we describe the data points under the variables, right? So we can draw simple tables, right? We can draw frequency distributions, right? And when we look at this simple table and the frequency distribution, contains some numerical figures, numeric data, right? Suppose you analyze your data set, and after analyzing the data set, you have to prepare some reports in your working place. At your working place, sometimes you have to prepare reports, so you have to present your results to the management in the meetings, right? At meetings, you have to present your results. So when presenting, you have to think whether you are going to put for your presentation, whether you are going to add this table, right? This table, or whether you are going to add this plot, this graph. You can decide according to the audience you are going to present the result. You can decide whether you go for this table or this plot. Both gives the same information. Right? By looking at this table, I can say that the cereals, cropping type cereal, use the highest area. Right? In highest area, we can see the cropping pattern cereals. Right? So in this graph also, can see the highest area goes for the cereals. Right? So there is a important point when deciding which method you are going to add to your presentation. It depends on your audience. Sometimes suppose that your audience is the farmers, right? Farmers in very low educational level, with very low educational level, they have no any mathematical backgrounds, right? They cannot read these, right? It is difficult to read and understand these numerical figures, right? Then what you can do? You can use this. You can use this bar chart. You can, when you plot this bar chart to them, they can understand something. Right? The height of the bar is high under cereals. They can understand that cereals are in high area than the other, and the cotton cropping type is represent a very low area. Right? Rather than going through these numerical figures, they can easily understand what you are saying. You can pass your message very easily to the audience, right? So after analyzing the data, it is important to present it, right? Preparing the slides, reports, it is very important part, right? And so please try to understand. We are talking different types of table, tabular presentation, different types of graphical outputs. What's the difference, right? I said you, according to the variable types, we can use different outputs. Right? This is a bar chart, simple bar chart, right? So you have a homework here also. Draw the same plot considering y-axis as the percentage of area, right? Calculate the percentages for each column, right? Each row, each crop type, calculate the percentage area and draw the bar chart. Draw the bar chart like again, like here for the y-axis. Now you have the percentage area, and here x-axis you have the cereal type, oil seeds, pulses, cotton, right? This one, last one is the others. So you can plot, right? And the total is now 100, And so the maximum number goes here to 100. Calculate the percentages and draw the graph. Can you do? Right? How we calculate the percentage column? Right? In the here you can construct another column and percentage area. Right here, what is the area percentage out of this one? Out of total area 6,827, we have the area 300,985 was area. Then if the total area is 100, so what is the percentage? So like this way, you can calculate the percentage area for each category. Now tell me, what do you think? Can't you draw a simple bar chart for this data? Yield data. Can't you draw? Why? You can't draw actually. What's the reason? What's the reason?
It is the quantitative data. Yes.
Right, exactly correct. Right. The reason is these data are quantitative. Right. Here, the yield is a quantitative variable. It represents some quantities, but simple bar diagram we use for the qualitative variables. Like for the qualitative variables, we have the data like in categories, like gender, male or female, cropping pattern, like cereals, oil seeds, like that. Right? For education qualification, we can draw a simple bar chart. For the x-axis, we get the categories, data categories. But here we cannot identify the categories, just we have some numerical measurements. Right? For this type of data, you cannot draw a simple bar chart. Right? If you, the problem is this, now this is the theory, right? Now you know manually how we draw frequency table and the simple bar chart. But suppose when you are using a software, right? Suppose in Excel, you have this data in a column. And if you say the software, draw a bar chart for this data, the software gives the output. Some softwares gives the output. It considers each data point as a category and give a meaningless output. Right? Because of that, we say, before analyzing the data, you should have the theory knowledge. You should have the theory knowledge because what you are asked to do for the software, it gives. Sometimes the software gets stuck because you give the wrong variables to get the plot. If you give this type of a variable and ask to get a pie chart, right, or bar chart, it gives a meaningless output. Right? So keep in mind what you want to plot, how you want to analyze this, what is the descriptive method you need to use according to your variable type. It is very important. Right? Please complete this one also. And there are several types of bar charts, multiple bar charts and cluster bar. It's called as the cluster bar chart. Another bar chart also, the composite bar charts, right? Here we talked about the multiple bar charts only. For when you have more than one categorical variable, we can use the multiple bar chart or cluster bar chart. Please read this problem and you have given the data. Read this problem and see how many variables are there. Identify the data types, variable type, and see how this table, right, rather than putting this type of a table, we can draw this plot. We call this plot as a cluster bar chart. Here, bars are, we can see bars are as clusters. Read the question. Right, can you identify the variables? It says two variables are there. The average yield of different varieties of green gram was recorded, right? What it recorded? Average yield of different varieties of green gram, recorded under different method of irrigation. Right? Actually, when I explain the collected data set for this, it's like in your Excel sheet, you will have this type of a data set, right? You have the yield and the variety and the irrigation method. Three variables, right? Actually, yield is my collected data. With the yield, you have the other two information collected, right? Right, for some, let's see some certain plots. For the first plot, yield is 3,200, right? What's the variety? Under variety 1, irrigation method also 1, right? Then this one, 1,500 yield. Second one, 1,500. Variety 1, irrigation method 2, right? Variety 1, irrigation method 3, yield this. Variety 1, irrigation method 4, yield 1,566. Variety 2, irrigation method 1, yield 1,800. Right? Like this way, here you have, this is the original data set. This is the original data set. It has the three variables and this is your collected data set, right? This data we can summarize in both ways, like this type of a table, right? And this type of a graphical output using cluster bar chart, right? What this bar chart shows, bar chart, it use for the x-axis, it use one qualitative variable, it use for the x-axis irrigation method, right? Irrigation method, we have for the irrigation method, 4 types of irrigation methods, like 1, 2, 3, 4. And for the y-axis, I want to plot the data yield. My data points are yield, right? I want to plot the yield under irrigation method and the variety. Under irrigation method 1, we have the information for the 3 varieties. Variety 1, 2, 3, right? So here these shading, different shadings represent different varieties. Right? This one for variety, right? This pattern shows variety 3. This pattern shows variety 1. This one shows variety. This is for variety 2. So under irrigation method 1, variety 1 yield 3,200, right? 1 bar. Variety 2, 1,800. Variety 3, 3,985. The bar height is higher than this. So, cluster. It's a cluster of different bars. Same width, but the height is different. Right? So this is we call as the cluster bar chart. Then you can plot for under irrigation method 2. What's the variability of the yield under different varieties? Is it clear? Do I need to explain it again, or is it clear? Do you have any questions? Please ask.
Yeah,
Right?
madam.
Is it clear? Please do
Yes, ma'am.
this. Right? Please complete this, because in your exam you have to draw this type of manual, this type of graph using manual. Right? This is also another important graph. Mainly we use for categorical type data, right? When you look at this figure, it's like a circle, and these are we called as pie slices. So we call this as a pie chart or pie diagram, pie chart. What's the variable here? Pie chart for the variable. Right here for the variable. For the variable gender, we have this pie chart, right? So the variable gender, it has only 2 categories here. In the right-hand side, we need to mention the 2 categories in 2 colors or 2 shadings, right? The percentage under each category, we can plot within using a slice. Right? So the female percentage is 38% and the male percentage is 62%, right? So in the pie chart, categories of the data represented using slice are proportional and they are proportional in size to the percentage of individual under each category. According to this proportion, we draw the 2 slices. I draw 2 slices because I have only 2 categories for this variable, right? So this is 62%, this is 38%, right? If we have total is 100%, right? So for this, to draw the pie chart, you should have no missing data points. All the data points should be there. If you have the missing data point, use another slice to represent the missing point, right? So if you suppose you draw a pie chart for the variable like education qualification, it's a variable, and the first person education qualification O level, second one A level, third one again O level, and suppose we collect the education qualification into 3 categories: O level, A level, and degree. So you can simply draw a pie chart, or you can draw this type of a bar chart and a pie chart. If you draw a pie chart, it contains 3 slices. Right? This is the pie chart. Another one question regarding the previous one in the chat box. Can we draw two variety data in one chart? Yes, here we have the two variety data in one chart. In one chart, can we draw two variety data in one chart? Not two, three varieties we draw in one chart. Right here I have three varieties. I draw the three varieties under different irrigation methods in the one chart here. Okay, right. Right, it's clear now, right? Right, any questions from the pie chart? So you need to understand that, like in bar chart, pie chart is also suitable when you have qualitative variables, right? For the variable like pulse rate, student marks, you cannot draw a pie chart. What will happen in that type of a case, if the software considers these individual data points as categories and draw a pie chart or bar chart, it is not the correct output. Right, so now there are several some disadvantages also, right? Now please see here, you have two pie charts created and some points given to you. Please go through these 2 points and try to understand what it says. Right here, what we can see, there are two pie charts. The first pie chart shows the ethnicity of student, and the second pie chart also the same thing, but in two different ways, right? There are several types, ethnicity types: Asian, Black, Hispanic, White, Pacific Islander, like several types, categories. This pie chart, see, we cannot see any. This is a pie chart according to the 1, 2, 3, 4, 5, 6, 7, 8. 8 number of categories. It used 8 slices, right? 8 slices, and according to the percentage value of the slices, it draw this pie chart. But here 36%, here 5%, 6%, 5%, 17%. But it is not clear. This one is not wrong, but this is correct figure, but this figure is not good. But I can say that rather than this one, this is more good, right? The chart in figure B, what's the reason for saying that? The figure B chart organized by the size of each slice. According to the size of the slice, it organized. So it is very easy to understand by the others because these very few numbers are not important, right? Here we can clearly show these high numbers because it organized according to the slice size, which makes more visually informative graph. Right? This is more effective graph than graph A. Right? Because here it draws according to the alphabetical order. Right? But you should think about whether rather than drawing this type A graph, if we can give this type of a graph, it is good. Right, the other thing, and in the drawing the pie charts also, sometime when collecting the data, suppose here when collecting the data, I ask the student what's your ethnicity group, right? I can give several alternatives, Asian, Black, no, Hispanic, like I can divide like several categories, I can give several options, several alternatives I can give to mark as the ethnicity group. But if there is any student who has another type of ethnicity group that is not in these categories, within the categories, to fill his answer, right, we need to put other category always in the question, yeah, with this type of a way that is giving several alternatives, we always put the other category. Then those who are not belongs to these ethnicity groups, he put a tick mark, his response under other unknown category. We include that one also, right? And if too many categories are there, suppose your variable contains too many categories, right? Suppose your variable contain 25 number of categories. You have in your the ethnicity groups, you have 25 number of categories. When you can draw a pie chart, but sometimes it is not clear. It will not be a good graph because the number of slices are high, right? Then it will most probably it will not give a good graph for you, right? What you can do, you can reduce the number of categories. You can plot here, right? You can in this graph also, rather than drawing all these 8 categories, these are the main categories, right? You can plot these and you can put these 4 categories, put all these 4 categories into one category as the other. For the other category, you can put all these 3. And then it is a simple graph. Got it? Any questions? Right. This is also another important plot, right? The name is the histogram. Histogram. The name is, this plot is the histogram, right? Here you can see in the x-axis, for the x-axis, you have the data 59.95, 61.295, 63.95, like this way you have the data. Here you have the data. What are this data? This x-axis, right? Here the x-axis shows your variable. What is the variable here? Height. You have height data. Suppose you have the collected heights data for certain group of students, right? Like this case, like pulse rate, right? Here I have the yield. Like for this example also, the suitable graphical output is the histogram. And here I have the yield for 100 cases. I have the 100 data points yield. How I present this? How I display this using a graphical output? You cannot use a bar chart or pie chart. You cannot use those, right? What you can use a histogram, right? The graphical representation of the frequency distribution, right? How we summarize this data, the pulse rate of the student, I summarize using this type of a frequency table. This is the tabular summary. The graphical output of this tabular summary we called as the histogram, right? So in the histogram, you can see a special thing. In the x-axis, you have your variable, and the y-axis, you have the relative frequency, not the frequency, relative frequency. And here you can see several bars. Tell me, what is the difference between the bar chart and the histogram? Visually, when you look at the bar chart and the histogram, what is you can see some important point. When in the drawing, you can see some important point. What is it? As the bar chart, you have several bars with equal width, but the height of the bar is vary, right? There is another important point in this graph. In this graph and the bar chart. What is it? What is the difference? Right, if I draw the bar chart for the variable gender, right, if I draw bar chart for the variable gender, here for the x-axis, you have the variable gender. It has two categories, so I mentioned the two categories, male and female. And here I get the frequency, or you can get the percentage or relative frequency, right? According to the percentage value of the frequency, I draw for the two categories, I draw two bars. So what is the difference between these two graphs? Both has bars. In the x-axis, for the x-axis, you have the variable, right? But what is the main difference you can see? The bars in the bar chart and the histogram. What is the difference? That is a special point. Think about the variable type, right here variable type.
we use normally bar chart for the categorical type variable, categorical data, or we say qualitative data, which represents some qualities, data like in some categories, right? But I draw the bar histogram for the variable like this, that is the quantitative variables. Quantitative variables mainly in ratio interval scale, ratio scale data, right? For the quantitative variables, quantitative, like for the student marks, I can draw a histogram. Student pulse rate, I can draw histogram, right? Volume of trees in a forest, I can draw histogram. Yield of a plant, tomato yields, you can draw the histogram. So what's the difference between the bars in the bar chart and the histogram? What's the difference you can see? Can't you see any difference?
Gaps between two bars.
Sorry? The gaps. Very good, right? The gaps between the bars, right? In the histogram, there is no any gaps between two bars, because this is a continuous variable, continuous scale data you have, right? If we say the heights of the student, I say that heights of the student according to this scale, height of the student can vary from 50 to 80. It can take any value in between these two, including the two values, right? So there should be no any gaps. But here, gender, just categorical, the data is like categories, male or female. Education qualification, like O level, A level, or a degree, right? You cannot draw a bar chart like for the O level category, this, right? Like without keeping the gaps. This is for O level, this is for A level, this is for degree. You cannot draw the bar chart like this. This is a histogram, right? This variable is not a continuous scale variable. It has only the categories. But here, the variable is a continuous scale variable, so you cannot put gaps between the bars, right? That's the point. So you can now you can understand that what's the reason that we talked about when we talked about the frequency distribution, right? When we draw the frequency distribution, we draw the class intervals and the frequencies. But we talked about another point here, the class boundaries. Class boundaries, right? When I draw the frequency histogram considering the class intervals, here you can see there is a gap between 56 and 57, right? Then I can draw the histogram like this, then 47 to 56, bar height is this 3. Then 57 to 66, bar height is 26. Like this way, there is a gap. So this is not a histogram, right? Because this x-axis, you have the pulse data, it's a continuous scale variable, right? So you should consider the class boundaries with the relative frequencies, right? So this is very important. In statistic, this output, we call this as the histogram. Any questions? It consists of the joining bars. The horizontal axis labeled with what the data represent. Vertical axis, the frequency. We can use the frequency or relative frequency. Right? Now let's see. Right? You have given this example. and see how we you have given the frequency table and the class boundaries with the relative frequencies, and this is the histogram of this data. Now see how many, now by looking at this raw data, I cannot get any idea, right? It's very difficult to say something by looking at this information. What this data says, the following data are the heights of 100 number of males. The heights are continuous data, right? It's a measured value. It's a continuous variable. I cannot say anything by looking at this raw data. But rather than the raw data, by getting this frequency distribution, I can tell something more than something more, right? I can say that most of the students' heights are in this range, 64 to 71.9. Most of the students, right? There is only one student in 74 to 75.9, but I cannot understand it from this. Right? So rather than this one, if we get the percentages also, right? If we get the relative frequencies, it is more important. Like the relative frequency here, the total is 100 out of the total. This one, right? The relative frequency, right? For this one, the relative frequency is 5 over 100, right? Here, the relative frequency is 3 over 100. Total is 100 number of points. Right? This is the frequency distribution of the heights. This is the relative frequencies with class boundaries. Class boundaries. Here you can see the actual data points are in 1 decimal place. Right? In your frequency distribution, you have the actual data points as the class intervals. 60, 61.9 like this, right? Now using this class intervals frequency distribution, we can create this class boundaries, right? Because to draw the histogram, we need this class boundaries. So how I create the class boundaries? This boundary, first I get this boundary I get from considering this one and this one. It is 61.9 plus 62 over 2 is 61.95, right? Then the same boundary goes to here. Then this we calculate using 63.9 plus 64 over 2, right? So then you can, according to the way the boundaries goes, you can imagine the class interval here and calculate the value for this. Other than that, you can write it by considering how the values goes. You can understand this. This should be 59.95. Now using this plot, this table, you can draw the plot. Frequency, this relative frequency distribution with the class boundaries, we can plot the histogram, right? So the 59.95 to 61.95, then 61.95 to 63.95, 63.95 to 65.95, 65.95 to 67.95. So we plot the frequencies. So this is the histogram. And I can say that the highest number of students are in this range, right? Because the height of the bar is this much, right? This is the highest number of students in this range. Their heights are in the highest number of student height are in this range 65 to 67.
And when we look at the overall distribution of the heights of the student, right? I can draw this type of a curve, the overall shape. The overall shape, I think you have heard about under O level. Sometimes, right, in O levels, we talked about the normal distribution, like the asymmetric bell-shaped curve, right? We call this type of distribution as it is symmetric around zero, bell-shaped curve around the center, right? Around center, this is symmetric. So by looking at this overall shape, I can say the heights of the students are symmetrically distributed. Symmetric, right? So sometimes we will get a shape like this, right? Like this type of way, overall shape. Or sometimes if we get a shape like this, right? This is not symmetric. These are not symmetric. These are skewed to here. This is skewed to here. But this is symmetric around the center, like that, like this case. So I can interpret the heights are symmetrically distributed. Well, the heights are symmetrically distributed. Right, so how we draw the histogram and describe it. Any questions? Could you please get a few minutes and go through the data, right? Please go through the data and the frequency distribution. And in your exam, I'm not expecting like if I give the raw data, constructing class intervals and the frequency distribution like this. But if I give the frequency distribution, you should be able to create the class boundaries, right? Just calculate the class boundaries considering these limits, right? So you should be able to create from right? If I give the frequency distribution, you should be able to create the class boundaries and draw the histogram, right? So don't worry about big calculations, right? I'm not asking big calculations in your exam, but you should have the concept, right? You should understand the theory. Right, get a few minutes and please go through these, and if you have any questions, you can ask.
Yes, I will upload some tutorial for you, some questions, so then you can practice, right? And I will upload the last time question paper. Right, so you can practice this one here. This is very simple one example in your course manual, page number 27. Page number 27, you have given the dBH values, right? For the 80 decrease, the frequency distribution is given and you are asked to draw the histogram, right? Simply, you can plot it considering the class boundaries, right? So here in this plot, here this plot gives the final plot. Here it doesn't show the class boundaries, right? When you are plotting this, right, when you are drawing this, you can create, you can write, you can draw here, you can indicate the class boundaries, right? The class boundaries here 11.5, right? Like 12.5, 13.5, not 10.5, right? 12, 13.5, then 16.5. You can draw the class boundaries and draw the histogram. But in this figure, it shows not the class boundaries. This figure, they shows the class midpoint value. This is also okay, right? This is also okay. Some shows the class midpoint, 11 plus 13 over 2, that is the 12, right? 14 plus 16 over 2, 14 plus 16 over 2, 15, class midpoint with the relative frequency, right? But you can, this is also histogram, but theoretically we draw it considering the class boundaries, right? Without showing class boundaries, you can show the class midpoints also. Right now, this is when you're analyzing the data, this plot also really important, box plot, right? We call to identify the unusual observations, to identify the shape of the distribution and also identify the outliers. Outliers, or we can say that unusual observations, we can use the box plot. This is the figure of the box plot. It contains a box. It contains a box, right? Box. And in this box, this is how we actually in manual calculation, this is the graphical output. This is the output given from the Minitab software, Minitab, right? It uses some mathematical calculations when drawing this box plot, but when we are drawing the box plot manually, how we do it using 5 number summary. That is, we use these 5 numbers. Minimum value of the data, maximum value of the data, Q1, Q2, Q3 values. I will explain these values in next slide. The first quartile, second quartile, and the third quartile, right? Suppose you have given these 5 number summary, these 5 values, then how I draw the box plot, that is for the data like right here, you can see the data is the weight for the continuous variable or the quantitative variable, right, for this type of data. Suppose from the data, it calculates the calculated values for the minimum value 60, maximum value 74, and using this given data, we can calculate this Q1, Q3, and Q1, Q2, and Q3. Because you have this, when you have this data, how we draw the box plot, right? Manually we draw it as this way. We create a box, right? This line shows Q1, first quartile. This upper line shows Q3, third quartile, right? The middle one is somewhere in the middle. It shows the second quartile. Then from this end in the box, the bottom end, we draw a tail up to the minimum data point in the data set, right? And from this end, we draw another line, tail, we call these as tails, to the maximum data point in the variable. This is simply how we manually draw the box plot, right? Use this 5-number summary. For the box, we use Q1, Q2, Q3, and minimum and maximum values, right? You can draw the box plot in this way also, right? For this way, considering this point as Q1, this is Q3, then the mid value is here, right? If you know the value, we can draw this correctly. So this is the minimum point of the height. This is the maximum point is the height, right? We join this point to this end using a line, tail. It's the box plot. So, but this graphical output, it draws as the same way, but there is some calculation when it drawing. Here, this is the weight vary from 100 to 200. So this point in the box, say as same Q1, this is Q3, right? This middle line Q2, right? Here, this is not the minimum and the maximum, right? Minitab use some mathematical calculation, and it creates these two endpoints. It creates these two endpoints. Actually, sometimes these two endpoints are not the minimum and maximum value of your data, right? And what the software does, if there are any values beyond these two limits, right? Some mathematical calculation, it creates these two limits. If there are some values beyond these two limits, it shows those values as using star marks. Star marks, right? Suppose there are two values here, use two star marks. If there is another value here beyond the minimum point, according to the calculation, according to the Minitab calculation, this is a minimum point. Minitab calculation, this is the minimum, but it is not some, right? It is not the actual minimum of the data. Actual minimum is here, right? It, according to the this two calculation, it says there are some points those are unusual or outliers. Then we have, when we analyzing the data, if we saw these type of star marks, we can think about it, whether these are unusual, actually unusual, or whether we need to remove this data from the data set before analyzing. You want to think about, right? Suppose here, although these are star marks, these are not unusual. Weight can be something like this 200, more than 200 values, weight can be, right? So these are not unusual. Suppose there is a data point like weight 10, right? So we will get the star mark
here, sometimes it shows as a oval shape, circle, right? Extreme outlier. This is the weight value 10. Weight is equal 10. That means by looking at this graph, I can see that when comparing with the rest of the data, there is a person having weight 10. It cannot happen. Actually, when you consider the rest of the data, the weight of the person vary from 100 to 220. But there can be a person with weight 10. That is some wrong data point. Sometimes 100 when data entering, 100 entered as 10. Okay. So that type of things can happen because we collect the data and we enter the data to the software. After that, we analyze. When entering the data, there are some mistakes can happen, right? So we can identify those like unusual data points. Here, this is unusual. When comparing with the rest of the data, 10 is unusual. Definitely, I have to remove this data from my dataset. Other than my conclusions will be wrong. Right? So this plot is very important to identify the outliers and also the shape of the data. Right? You can say that the data shape is like this, right? Like the data behave like this way or a shape like this. So box plot can provide answers to the following questions. Is a factor significant? Does the location differ from the groups? Does the variation differ between the groups? Are there any outliers? Right? That means we can suppose I have the data for the weight for male and female. I can draw two box plot. Considering for the x-axis, I can consider the gender, male and female, and I can draw two box plots. Right? So this one is very important mainly in identifying the unusual data points. Okay. Any questions? Next, we can talk about the calculation of summary measures and the scatter plot and how we calculate the summary measures. Right? So shall we get a 15 minutes break? Now the time is 2:47. Shall we get a 15 minutes break and I will start the meeting again at 3:05. Right? We can start, I will start the lesson again 3:05. So please join. We have to finish. It is good we can finish this part also. Right? So you can practice those things because these are really important points, right? No need to use manual calculations. Today we have the software, but you want to know what's the meaning of these things, right? So any questions? Right, then please join again at 3:05. Right. Now, this is another graphical output. This is important to present the data, to display your collected variables. We call this graph as a scatter diagram, scatter plot, right? Mainly, this graph is used to show the relationship between the two variables. The relationship occurs in a sample of ordered X and Y pair, right? So this is a scatter diagram. Mainly we use this to show the relationship between the two quantitative variables. Right, two quantitative variables. For an example, suppose I want to identify how I have the data like this. Some group of persons pulse rate and their weight. I have this data, pulse rate and the weight. Right? I want to check what is the relationship between these two, pulse rate, some value for the first person, and his weight. For the second person, his pulse rate value and the weight. Let's write these values as this way, right? That now pulse rate value y, simple y1, this is x1. This is y2, x2, right? For the third person, weight value x3, the pulse rate value y3, like this way. Suppose I have 100 number of data points related to 100 number of individuals, weight x100 and pulse y100, like this, right? So, now these two variables, pulse rate and weight, both are quantitative variables, continuous data, continuous variables, quantitative variables. To identify how the pulse rate vary with weight, what is the relationship between these two variables? One variable behave as X variable and one variable behave as a Y variable, right? For in the XY plane, right? In the XY plane, we consider these two variables as X as the independent variable and the dependent variable. Y we called as the dependent variable. Dependent, both are variables. Dependent variable, X, independent variable. Independent, right? So now we know that now if we practically think about the pulse rate and the weight, right? Sometimes pulse rate can be vary according to the person's weight, right? When the weight increases, pulse rate also can be increases, right? So there is a relationship between, there may be a relationship between these two variables. For the x-axis, I select weight. Y-axis, I select the pulse, right? So now we plot this paired data. Weight x1, pulse value y1. Put a dot. Weight x2, pulse value y2. x2, y-axis, pulse value y2. Right? Like this way, I plot these paired data. We call this, we have some dots and the two variables. We call this as a scatter diagram. Scatter diagram, right? Here we can say that by looking at this scatter diagram, this is the X
variable, and this is the y variable, right? This is the independent variable. We can say that when x increases, y also increases. Right? This star mark shows this paired data. This paired, right? XY pair. A variable x and y related. Are the variables x and y linearly related, or there is a nonlinear relation? Right? So whether there are any unusual observations, we can identify a lot of things when we plot the data using a scatter diagram. The important point is to identify the relationship between the two quantitative variables. We use the scatter diagram. Right? So this plot is a scatter diagram, and right. You have this example. Please get 2 minutes and try to draw a scatter diagram for this data. You have given the two variables x and y. The following sample observations are selected from an experiment. Plot the data and comment on the relationship between x and y. Please draw the scatter diagram. Any questions? Right, you can draw this for the x-axis. Get the x variable here, x, and for the y-axis you have right, this is the y variable. For the x data, the minimum value is 3 and the minimum value is 3 and the maximum value is 8, right? So I mark here 0, 2, 4, 6, 8. And for the y-axis, we have the data like the minimum value 5 and the maximum value 77. Right? So for the y-axis, I mark this way like 5, 10, 20, 30, 40, 50, 60, and 70. Right? 70. Right? So now mark these paired data points. When the x value is 5, y value is 13. Right? This is the point. When x value 3, y value 15. X value 3, y value 15, the point. X value 6, Y 77. X6, Y 77, right? X3, Y12, X3, Y12, X3, Y12, like this one, right? Then X4, Y13, X4, Y13, X4, Y11, X4, Y11, right? X6, Y9, X6, Y9, right? X8, Y5. Now what you can say? Now it says the plot the data. Very easily you can plot the data. The important thing is comment. What you can comment by looking at this figure? What you can say? What you can say? What can you say? You can say that what about, right, this one, this point? By looking at the overall data points, right? By looking at this graph for all the data points, can you see this point is unusual? This point. Can you identify this point is unusual, right? Most of the X values, Y values vary in this range, right? Below 20. But there is an unusual Y value when X equals 6. Sometimes this may be 7. When entering the data, it's entered as 77. So first you need to check the data set, right? Whether this is a correct one or not. If it is 7, you can correct the data point and plot again. Otherwise, here you can say that you can remove it from the data point. When you remove it, right, your data will be lost, right? The number of data points in your data set will be reduced. So now we can say this is an unusual data point, and we can see when X increases, Y, right, the Y decreases. This type of a pattern relationship we can identify. This is how I comment this graph. Any questions? Right, here this is another example, right? You can practice this one. Here more data points are there for the 48 elderly men, systolic blood pressure and their diastolic blood pressure values. Systolic blood pressure, right? This is one variable and this is another variable. These two variables are measured for a sample of 48 number of persons. We are asked to draw a scatter plot, draw a scatter diagram and comment. Right? This is the scatter diagram. And you can select X and Y variables and plot. You can see when the diastolic blood pressure increases, systolic blood pressure also increases. And there are no any more unusual value. This is little bit unusual, but we need to check it, right? Sometimes this can happen. Right. This is another plot we can use to present quantitative variables, not qualitative, right? Quantitative. One variable, we call this as a stem and leaf plot. Stem and leaf display, right? For the disease plant example, this graph shows the stem and leaf plot. How we draw this stem and leaf plot? To create the stem and leaf plot, divide each observation of the data into two cases like stem and leaf. Leaf, always the final digit goes to the leaf, right? So when we have the 23, this is the leaf, right? This 430, leaf is 2, 43 goes to stem. Then draw a vertical line, divide each data point into stem and leaf and draw a vertical line, right? To the right, we get the stem. We write the stems here and, we get the stems here and this we have the leaves. Then write the leaves in the increasing order to the corresponding stem, right? So this one, that is how we read the data point. This is 32, 33, 33, 37. This way I can read the data points 32, 33, 33, 37, then 20, 20, 21, 21, 21, 3 21s, then 3 22s, 23, 28, 28, 29, 10, 10, 1, 2, 1, 2, 1, 4, like this way. The last data point is 9. Right? So this is the raw data. This is a summary format of the raw data, stem and leaf plot. From the stem and leaf plot also, we can get some idea about what is the shape of the distribution. Right? What is the shape of the distribution that is here? We can see the data behaves like this way, the overall shape. The overall shape is like this way. And we can say there are, rather than the raw data, by looking at this, we can see there are 1, 2, 3, 4. 4 18s, right? Then 4, there are 3 14s. Like that, we can get some summaries. Data like symmetrical distribution. This is the minimum value and the maximum point. Right. So this example, please consider the following data, which shows the disease plant trees in different blocks, disease plant trees, and draw the stem and leaf plot to present the data. This is the stem and leaf plot. Right? Please go through these data points and try to get this stem and leaf plot. You have to, each data point, you have to divide it into two parts, stem and leaf. Right? After that, draw a vertical line and write the stems. Write the stems here, and under each stem, arrange the values in ascending order.
numbers to the right. Any questions? Right, then next this explain you the purpose of the stem and leaf display. So also we can talk about the shape of the distribution, whether it's symmetrically distributed or whether it is skewed to one side, like. Now the next one is the frequency polygon, right? It's actually frequency polygon means in the histogram, right? In the histogram, what we do in the histogram by connecting these midpoints, but by connecting the midpoints of the histogram bars, right? We draw a curve, right? Here we consider another class boundary and get the midpoint. Here also we consider the highest class boundary and get the midpoint, and then connect these midpoints. This curve we call as the frequency polygon. It also gives us what about the shape of the distribution of the data. Right? And this is we called as the ogive, right? So I'm not going to talk more detail about this ogive because, right, this is some ogive means we using the class boundaries, right? Using the class boundaries, like we find the less than cumulative frequency and more than cumulative frequencies, and we draw these type of two curves, and from the ogive we say the intersection point of these two curves gives the median of value of the data. This one, right? This point is the median. Right? So we can talk about the median. So please go through this one, and this plot right here. This is this plot draws these two cumulative frequencies, this one and this one. Right, let's go to the central tendency measures. We discuss about the graphical methods, some graphs, bar chart, pie chart, histogram, box plot, scatter plot, stem and leaf plot, right? We talked about this graphical output, and also we talked about we can summarize the given data using frequency table. Simple table, simple frequency table, then table with relative frequencies. Right? We know we can summarize the data using some tabular form, or we can analyze the data using some tabular forms and some graphical representations. We call all these are descriptive statistics. Descriptive statistics. So I said you in descriptive statistics, what we do, we describe our data. Just describe. right? This is another method of describing the data. You can use summary measures. Summary measures to describe the data. To describe the data. Summary, we can use some summary measures. So we say descriptive measures to describe the data. What are those summary measures, right? There are 4 summary measures we can discuss. There are 4 summary measures. The first one is the measures of central tendency. We can talk about the center of the distribution, right? Or we can talk about the dispersion, right? We can talk about the variability, measures of dispersion. This is the second one, measures of dispersion. Variability of the data, measures of dispersion. Right? We can talk about the right. Another one is we can talk about the measures of skewness, and another one measures of kurtosis. Right? The most important are the measures of central tendency and the dispersion and the skewness. Right? Let's see what this says. What is mean by the measures of central tendency? Measures of central tendency. Right? Measures of central tendency means, suppose if I use the histogram, if I use this histogram, right, here we have the height data. The data presented as a histogram, right? By using this histogram, I can talk about what is the shape of the data symmetrically distributed, right? Here, this height data symmetrically like this way, it's like a symmetric shape, symmetrically distributed around some center, right? And also, the height data has some variability. Right? Data can vary from center to here and center to here. Right? We call it as the variability of the data. Variability of the data. Right? So we can talk about the measures of central tendency, measures of dispersion. Dispersion means the variability, and measures of skewness. Skewness means with respect to the symmetric distribution, whether this is skewed to left, the pattern like this, not like this, right? Or whether the data skewed to right, skewness measure. There is another measure, right? Kurtosis, right? It talks about the flatness of this peak relative to the symmetric or normal distribution, right? Whether my data peak means it has a flat peak or peak like this. We call this as kurtosis. So we can calculate some numerical measures to talk about what is the kurtosis, what is the skewness the data have. What is the dispersion the data have, variability of the data, what is the central tendency of the data. So using these measures also, rather than drawing the histogram, by calculating these measures, you can describe the height data. Right? So now you should understand these things. I cannot describe the variable gender using these measures. No, gender or education qualification, I cannot describe it using central tendency, dispersion, because it's not a continuous scale variable. It is not a quantitative data. Gender, education qualification, those are categorical, those are qualitative variables. We cannot talk about the dispersion. We cannot talk about the skewness. We cannot talk about the central tendency, right? For the qualitative variables. Here, mainly we talked about the measures, descriptive, these summary measures for the quantitative data, quantitative variables. So to talk about the center, we can use these measures. Mainly we use mean, median, and mode, right? Mean, median, and mode. What is the mean? Mean is the simple arithmetic mean. That is the mean is the, suppose you have the data points like you have 5 data points of weight, right here, like here in this example, to compute the mean, add all the values and divide it from the number of values. This is the formula for the mean, a simple arithmetic mean. Here I add all the n number of values and divide the from the number of observations. The answer gives the mean. So in notation, in this example, this one is like x1, first data point. This is the second data point. This is the third data point. This is the fourth data points, and I have only 5 data points. So the average of this we call as the mean of the data. So please calculate if the yields of 5 plots of the paddy are given here, find the mean yield. Calculate the mean yield. Right? This is how we calculate the mean. Mean yield is the summation of the data points divided from the total number of data points you have. Any questions? Right, there are several formulas we can use to calculate the mean according to how the data are given. Right? Suppose if you have given the data like this way, that is, if the numbers x1 up to xk values occurs f1, f2 up to fk frequencies, occurs these times, right? In other words, occur with frequencies f1 up to fk, the arithmetic means we can calculate using this. That is the number x1, it repeats f1 time, right? Plus number x2, you have x2 values
F2 times frequency. And you have xk values up to k number of times. So now divide the from the total number of observation frequencies of k number of frequencies. This gives the arithmetic mean, right? How the data gives, that is, suppose you have given like this table like weight and the frequency, number of students. Weight 130, number of students 5. Weight 150, number of students 3. Weight 155, 1 student. Weight 160, we have 2 students. Suppose you have this data, then how you calculate the mean weight? The mean weight is, we have 5 130s, right? Plus 3 150s, 150s 3, plus 1 155, plus 2 160, right? So we get this summation, divide this from the total number of data point. 3 plus 3, 6 plus 5, 11. This gives the answer. For this, when you have to calculate the mean for this type of data, that is, consider the following frequency table and calculate the arithmetic mean, right? This is the frequency table, the class intervals and the frequencies. So to calculate the mean, here I have no, from this frequency table, I have no individual data points. I know there are 80 number of data points with the frequencies and the class intervals. No individual data points are there. So then how we calculate the mean? We consider the midpoint of each class, right? The midpoint of this is 12. The midpoint of the second class is 15. The midpoint of the last class is 24. So I calculate the midpoints and get the mean. Mean means there are 100 and midpoint 12, right? With frequency 11, right? Plus 12 times 11. Then midpoint 15, 20 data points, right? 20 plus midpoint 18, 30 data points. Like this way, you have to get the summation of all, that is midpoint 24, 4 data points. So we get the summation and divide this from the total number of trees, 8. Get the mean. Any questions? There are several special names for these means, right? But these are not rarely used, but some special cases we have to use. Sometimes we have to calculate the weighted mean according to the problem, right? It depends on the problem for which data you want to calculate the mean, harmonic mean and the geometric mean. Normally we have to use most of the time the simple arithmetic means, but in some cases we have to use the weighted mean. Right? Weighted mean means for each and every observation we give different weights. In earlier, when calculating the mean, we calculate the mean simply getting the summation of n number of data points and divide it from n. We give equal chance for n number of data points. Right here you can see this is the weighted mean. We give the weight W1 for data point x1, W2 for data point x2, Wn for data point xn, and divide it from the total number of weights.
Right? So some situations, the individual observations are not equally important. Right? All the observations are not equally important. In that case, we have to give different importance. We have to assign different importance by considering some weights. So we call this type of mean as the weighted mean. Right? Read this example and try to understand why it is important here, the weighted mean. Rather than calculating the simple arithmetic mean, here it calculates the weighted mean. What's the reason here? Right here, you can see the total aggregate marks obtained by a candidate. If we consider one student, his total marks for the 4 years in his degree are given like this. First year average total this 78, second year 58, third year 68, fourth year 52. Depending on the importance of the academic year, right? So here the academic years are not equal, right? So you have to do a lot of works in third year rather than in first year and second year. Right? So they have assigned some weight. The following weights has been assigned and find the mean marks for the candidate. Right? So we have to some way how we define those weights. Sometimes weights. Sometimes you need to go through the literature and identify how we assign the weights. And here it assigned 1 for first year, 2 marks for second year, 3 marks for third year, like 4 marks for the fourth year, highest academic year, right? So calculate the weighted mean, right? Multiplying each individual the value with the weight and get the weighted mean, right? This here we obtain 78 multiplied by 1. Plus 58 multiplied by 2 plus 68 multiplied by 3 plus 52 multiplied by 4. And we divide the whole quantity from 10. This is called as the weighted mean. And these two are some other special cases, like when we want to calculate the mean regarding this type of example, we use the harmonic mean. Right? The driver travels from city A to city B, from city A to city B, travel from a speed 2 kilometers per hour. On his return journey, he traveled at a speed of the return journey, the speed is 40 kilometers per hour. So when calculating the mean, it is wrong if we add these two and divide by 2. Right? When finding the average speed, you have to calculate the harmonic mean. That is, it is appropriate for the situation when the average rate is desired. Here we have to consider we need some average rate.
right? So when you are dealing with some rates or speed, average speed or average price, the harmonic mean can be used. Right, this is the answer, and this is the geometric mean. When calculating the geometric mean, what we do, we get the multiplication of the data points, x1 times x2 up to n number of data points. We get the multiplication and get the n square root. Right? So when for this example, the geometric mean of this data is 33916. Right? The geometric mean is the root of the product of 33916 and the one. This is n is 4. We have 4 data points. Right? So solve this one and you can get the answer. So mainly we are important central tendency measures under the mean, simple arithmetic mean and the weighted mean. Then next to talk about the center rather than the mean, we can talk about the median of the data. It's called the middle value of the data. Median is the score found at the exact middle point of the set of values, right? When we arrange the data set in ascending or descending order, the midpoint shows the median, right? When we arrange the data set, after arranging the data set in ascending or descending order, the midpoint value, mid value is the median. Right? So we can say that below the median we have 50% of the data and above the median we have the other 50% of the data. Right? See for this how we calculate the median for this data. Suppose you have weights of 7 persons. Right? Arrange the data. First, what we do, first you need to arrange the data in ascending or descending order, right? Arrange the data in ascending or descending order, then the mid value is the median. Right, this is the formula. That is, if there are n number of values in the data set, median is n plus 1 over 2 value. That is, median is here 1, 2, 3, 4, 5, 6, 7 data points. 7 plus 1 over 2 observation in the ordered data set. Now, what is this observation? 8 by 2, 4. Fourth observation in the ordered data set. In the ordered data set is here. This is the first observation, second observation, third observation. This is the median. Fourth observation is the median ordered data set. Right? If the number of observation is an even number, right? Here number of observation, here it is odd number. N is odd. N odd, that is 7. If the number of observation is even, right? How many data points here? 10. 10 is an even number. If the number of observation even, the average is the middle of the two values, right? So try to calculate the median of the data in example 2.6. First arrange the data in ascending or descending order, then find out the middle value.
Right, what is the median? If I arrange this data in ascending order, what is the lowest value? Lowest value 175. Then the next highest value 180. Then 183. Then 186. Now I use this one, this one, this one, this one. Then 201. Right? No, 191, 191, 191, then 201, then 209, right? Then 219, 220, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9 data points, right? So could you please add another data point here? Right? Here it should be an even number. If we have 9 data points, the middle value is what? Right? This to this one, this to this one, this to this one. And middle value is 191. Suppose write down this data point, the data point like 225, right? So the next highest value 225. Now what is the middle value? From this one to this one, this one to this one, we can cancel. This one to this one, this one to this one. So what's the median? Median, there is no one data point. Median is should be the middle value of these two. Because my total number of data points is an even number. Right? So the median is 191 plus 201 divided by 2. This gives the median. Right? Any questions? Right? For the group data, that is when you have the data in this way, that is the class intervals and the frequencies. Suppose you have given the data as class intervals, right? Class intervals and the frequencies, these two only. Right? No individual data points like 11 to 13, the frequency 11. 14 to 16, 20. Right? This is the last one, 23 to 25, the frequency 80. You have these two columns only, this table, right? The class intervals and the frequency. So then I have the individual data points. The total number of data points is, right here, this is 4, right? Total number of data points is 80. So then how we calculate the median, you have to use this formula, right? If I give this type of example calculation at the exam, I will provide this formula, right? So no need to memorize these formulas at the exam, right? No need to memorize these formulas at the exam. If you want some formula for the calculation, I will provide. As additional formula sheet, we can provide it, right? So no need to remember these things. Memorize these things at the exam, right? Because it is not useful, right? So it's a big formula and no need to, it's not useful for this calculation because what's the median, mean, those values also, if you enter the data to the software, we can calculate, right? So how we calculate the median here, according to this formula, L is the lower class limit of the median class. First, we want to find what is the median class. The class contain the median, L is the lower class limit. Summation of Si is the frequencies of all the classes lower than the median class. Right? Fm is the frequency of the median class and C is the class interval. So according to these definitions, you can find out the values and substitute. Right? So there are in 80, 40, 40 observations should be in the middle. So 40 comes right here, 11, 20 plus 11, 31. Then 40 belongs to this interval, this class interval, right? 17 to 19. Then using this class interval, substitute the values for these capital N, F, summation F1, Fm, like that, right? Fm is the frequency of the median class, right? N by 2, 80 by 2. Summation of F5 is the cumulative, the sum of the frequencies for all the classes lower than the median class. That is 31. Right? And 16.5 is the lower class limit. Right? Here, the lower class limit is the 16.5. So class width is 3. Right? Class width is 3. 11, 12, 13. 11 to 12. 11, 12, 13. This 3. So this is the median value. Right. Then what is the mode? Mode is the most frequently occurred value in a data set. Most frequently occurring value. Highest frequent value. Right. To find the mode, first we need to order the score data and count the values. Right. Here 0 we can see 3 times. 1 we can see 6 times. 2 we can see 4 times. 3 2 times. 4 1 time. 5 2 times, right? So mode of the data set is 1, highest frequent value. And also, right, so say when we see the histogram, right? When we see the histogram, the highest frequent value, so we have this, the highest height, right? This gives the highest frequency. Right? Here, the highest frequency related to the mode. There can be sometimes there can be more than one mode distributions. And so this is how we calculate the mode when you have the data as a frequency table. Right? When you have the data like this, how we calculate the mode. Right? How we calculate the mode. You have to substitute the values for this formula. Here F1, F1, F2. F1 is the frequency of the class previous to the mode class. F2 is the frequency of the class just after the mode class. And C is the size of the mode class and L is the lower class limit of the mode class. So first you need to identify what is the mode class. Right? Here also you have the data, class interval and the frequency. 11 to 13, 11, right? 14 to 16, 20. 17 to 19, 30. Then 20 to 22, 15. Then 23 to 25, 4. Right? So what is the mode class interval? First we need to find the mode class interval. Mode class interval is the class interval which contains the highest frequent data, right? So this is the mode class. So
frequency of the mode class interval before the mode class, right? Frequency of the okay, 20 means frequency of the class just after the mode class. Frequency, right, 20, right, the values are 20 and 15, 21, right? The just after the mode class 10 for the mode class, right? 15 over 15 plus 20, this is the upper limit of the mode class interval. 68.5, and you will get the answer. Please do this calculation, right? Do the calculation and see you can get this answer, right? You will get this answer or not. So each of the measures of central tendency has some strength and weaknesses, right? What it says. What it says. Right, now, to talk about the center, I have three measures: mean, mode, and median. I have three measures to talk about the center. But there are, in some situations, mean is good to talk about the center. In some situations, mean is not good to talk about the center. Right? These two graphs shows it. And when the data are symmetrically distributed, to talk about the center, all these three measurements are good. Because we say that mean, median, mode, all are in the same place. In the center, at the center, right? If there are any skewed shape data, right? These three central tendency measures are like this. If you have the skewed data like this, the highest frequent value is the mode, right? Since there are a few data points here, very, suppose this is 10, this is 90, right? So low data points are here, lot of high values and some few very low values, right? Suppose that when we calculate the mean of this type of data, skewed data, mean goes to this side. Mean, due to the effect of these few number of data, mean goes to this side. So this is the mean, this point. And in between these two, we have the median. Right? So when the data is symmetric, we say mean, median, mode, all are good. When the data are skewed, we say the mean is not good. Mean is not. Right. Now, this one, the following data, the PADI is from 14 plots, right? Are there any unusual observations? And also you have asked to complete the activity 6 in page 36, right? So for this one, what is your answer? Are there any unusual observations here? Right, for the 14 plots, the PADI is the data like 30 kilogram, 32, 35, 40, 42, 65, 62. But this is not usual. Right, 308,000. When comparing other data, this is unusual. Right? So to find it, if you have few number of data points, by looking at the few number of data points like this, by looking at this one, I can understand 3,800 is unusual, right? But when you have 1,000 number of data points, you cannot do it. You have to draw some plot to understand it, right? The main plot we draw is the box plot. To draw the box plot, we know that we need the minimum value, maximum value, and Q1, Q2, and Q3, right? So now we can talk about how we calculate the Q1 quartiles. There are percentiles and deciles, but mainly I talked about the quartiles only, right? You can go through the other percentiles and like the deciles, but quartiles is more important, right? So now with these measures also not we do not say these measures as the central tendency measures. These measures we called as some measures of location, some location in the data set. These measures shows, right? Where is the Q1? Where is the Q2? Some location. What is the data point for Q1, Q2, Q3, like that, right? So what means by quartiles, right? Please read this and see this diagram and understand what is mean by quartile. These are some 3 points in your ordered data set, right? Actually, the second quartile, this is the second quartile, Q2. Q2, we called as the second quartile. It is the median of the data set. When we arrange the data in ascending or descending order, the middle value is the median, or it is the second quartile, Q2, right? So now I know that above the median, I have 50% of the data, and below the median, I have another 50% of the data. Right? Then another 2 values like Q1 we called as the first quartile, and Q3 we called as the third quartile. Q1 is normally when we arrange the data in ascending or descending order. Here data arranged from smallest data point is here to the last data point is here, right? I order the data. This point shows the Q1. This point gives the Q1, first quartile, right?
this point gives the third quartile. So here below Q1, we have 25% of the data. Above Q3, we have 25% of the data, right? In between Q1 and Q2, another 25%. Q2 and Q3, another 25%. That's what the quartiles means. It divides the data set into 4 equal parts. These location points we called as the quartiles, right? These location points we called as the quartiles. So this is how we calculate the quartiles, Q1, Q2, Q3. The value at the n+1 position value, this point is the first quartile. n+1/4 times 2 position value is the second quartile, right? Then n+1/4 times 3 position value is the third quartile. Right? So these are the quartiles. So now let's see how we calculate these quartiles. Right? The quartiles using these formulas, how we calculate the quartiles. The following are the paddy yields, right? Paddy yields from 14 plots, and you are asked to compute the first quartile and the third quartile, right? You have given the paddy yields for 14 plots after arranging the data, arranging some order, right? So see, what is this, what this calculation gives you? Right. According to this calculation, how we find these Q1, Q2, Q3? You have the answers Q1 and Q3. So could you please write, try to find out these values. Right. Here this calculation it explains the calculation of quartiles based on the percentile, right? P25 is the first quartile. That is when I arrange the data in ascending order, descending order, right? In ascending order, if you have the 100 data points, 25th data point value is the 25th percentile, right? It is the first quartile. And the 75th percentile value is the third quartile, right? If we talked about these quartiles using percentile, this is the P25, this is the P75. So how we calculate P25 and P75, right? P here the percentiles. Percentile means are the values which divide the whole data into 100 equal parts. We divide the data into 100 equal parts, and the X percentile is the value below which X% values in the distribution, right? So X percentile value is the X percentile value. In the first, we arrange the data in increasing order. The X percentile value is n plus 1 over 100 item times X percentiles, right? So the 10 percentiles mean to X for the X we place 10, right? 10 total number of data points here 14 plus 1 over 100. So this is the 10 percentile value, right? 10 percentile value. P10 is the 1, right? When we solve this one, we get 1.5 item. So what is 1.5 item means? This is the first, second, third, fourth, right? That is the 1.5 means a value like here, 10 percentile, right? Value like here. So that is how we solve this one, like first item plus 0.5. 0.5 means half. 0.5 times second item minus first item. Right? 0.5 means 1 over half means 0.5. So then now we substitute the value first item 30 plus 0.5 times second item 32 minus first item 30. So this is the answer. So this is P10, right? So like this way, 25th percentiles mean in order to here what is X here, simple X is 25. This is we can call as the second quartile. So 25 plus 14 plus 125 times 15 over 100, right? That is 1 over 4. So this is 4, 3, 4, 3, right? 4 by 3, 12, 12 plus 3, 15, 15 over 4. So this is finally we get 3 over 4th item, right? 3 over 4th item means in the order data set, right? I want to find third item, right? I want to consider the third item and the fourth item, right? So that is the third item plus 3 over 4 times from this gap, right? That is fourth item minus third item, right? Third item is 35 plus 3 over 4 times fourth item is 38 minus 35, right? So we get the answer 37.25, right? So now I will give you this as a homework, right? So for this example, find the first quartile and the third quartile using the percentiles, and also try to do it using these formulas Q1, Q2, Q3. Using these formulas also try to calculate, right? So I think we can stop now, right? It is better to stop now because the dispersion measures is also very important part, right? But you cannot, I think, this time you cannot understand this thing if I explain. So we can talk this in next week. You have two sessions for the two groups, right? For the Saturday groups, you have the session on Saturday, and the Sunday you have the same session on Sunday for the Sunday group, right? So please go through all the things we discussed and go through the other parts in this lecture note, dispersion measures, and I have uploaded the lecture note for also. I will upload other lecture notes. Please go through these and try to do all the calculations, right? Try to understand those concepts and try to do all the calculations, right? We can talk about this calculation in next week. And please go through the notes and complete all your activities. Right. We can talk about the dispersion in next week. Right. So any questions? Right. After that, under the summary measure, we mainly discussed about the dispersion measures, and there is another important measure it is really needed for you, like coefficient of variation. You need to know about the importance of the dispersion measure and the coefficient of variation, right? Then we can talk about lecture note 4. I think we have the probability, some simple probability calculations, right? Probability distributions, what is meant by the probability, and how we calculate very simple probabilities, right? After that, lecture note 5, we can talk about some important probability distributions, like the Poisson distribution, binomial distribution, and the normal distribution, right? These important distributions only. And this one. And hypothesis testing, right? So this is very important, right? Hypothesis testing, what? There are several formulas, but no need to remember, no need to memorize those formulas at the exam. I will provide all the formulas if required, right? But you need to learn what's the concept behind the hypothesis testing. Right, so we can discuss about this, and the last one is some regression analysis. It is how we calculate the correlations and how we develop a simple linear regression model. Right, so I think it's enough for today. So any questions you have? I will upload some questions, what we have discussed from these things. I will upload some questions to the LMS, right? So please try to complete those things. Right, then if you have no questions, shall we wind up the session? Shall I wind up the session? No questions, I think. So then thank you very much for joining. And I will share the Zoom links for the next two class, right? So thank you very much for joining. And I will stop the meeting now. Okay? Thank you. I will upload the 2 recordings to the
Thank you, madam.
Recording stop.